ஓகே. ஓகே. அது கரண்ட் ரெசல்யூஷன் வந்து 780 438 போட்டிருக்கேன். அதையும் எடுத்துக்க மாட்டேங்குது. 780 இன்ட்டு 438 போட்டிருக்கேன். செக் வீடியோ ரெசல்யூஷன் ஓப்பன் பை பட்ஜெட்டுன்னு வருது. அப்படின்னா ஓகே. ஆ. ஓகே. அதான் இப்போ வீடியோ அதான் ஆக்சுவலாக வந்து பேசிக் வந்து 1366 இருக்குது. அவுட்புட் ரெசல்யூஷன் வந்து 780 438 இருக்குது. இந்த இருங்க வரேன். ஓகே சார். ஓகே, தேங்க்ஸ். ஆமாங்க சார். அது தெரியல, கொஞ்சம் ஃபஸ்ட் டைம்ன்றதுனால. ஓகே சார். அதுதான் தெரியல. நீங்கள் எப்படியா இந்த பக்கம் வருவீங்களா? இப்போ வரணும். லீவு. ஓகே சார். 12:30 மணி வரை தான். 10லேருந்து 12:30 வரலாம். 9 வரைக்கும் ஸ்டார்ட் பண்ணுவோம் இனிஷியலாக. ஓகே சார், தேங்க்யூ. இல்லை அம்மாவுக்கு வேலை இருக்கு, மீட்டிங்கில் இருக்கோம் சார். வாரிக்கிறேங்க. எல்லாம் வர ஆரம்பிச்சிட்டாங்க. Good morning, sir.
Good morning to everyone.
Sir, 9:30 தான் சார் inauguration start ஆகும் சார்.
Okay. But then your testing process and other things you finish it off, madam.
Yes, sir. Okay. It's going on, sir.
So as the tenants come in, they need the first 100 lot, to come inside.
Okay, sir.
Video off.
சேர் எடுத்துக்கு சின்ன அப்படி வை. A very good morning to everyone. This is Dr. Shanti, coordinator of the program. On behalf of the Department of Marine Engineering, Amet deemed to be University. It gives me a great pleasure to welcome all of you this morning to the 5-day faculty development program on future trends in shipping. I welcome our respected resource persons, beloved principal, It gives a great pleasure to welcome all of you this morning to the 5-day faculty development program. It gives me a great pleasure to welcome all of you this morning to the 5-day faculty development program on future trends in shipping. I welcome our respected resource persons, beloved principal, dean academics, HODs and faculty members of the various departments, participants from other institutions, my dear students. This program has been designed with lectures and examples to provide skills, encourage participation and exchange information. Today lecture of this program is given by two speakers. They are Chief Engineer Ramalingam Govindasamy, Disney Cruise Ship as Drydock, Superintendent Engineer USA, and Dr. Vijay Rajeshwaran, Managing Director VI Microsystem. I welcome you once again, and I wish all 5 fruitful days be interesting and beneficial program, and also that you have a good health, and also that you all have a good health. I am handed over mic to Miss Sindhuja, Assistant Professor.
Navish Rajan, are you able to hear me? Good morning, sir. Good morning.
Good morning, sir.
Good morning. Navish Rajan, can you hear me?
Yes, sir. Hear you loud and clear.
Okay.
Good morning.
Wanted to have a session today.
Yeah.
If I am free, I'll take it. Otherwise, I'm taking my daughter for Kovacs, you know.
I got it, sir. I already replied to you.
Okay.
And no worries.
Okay, just only for today only. Okay.
Okay. Fine.
Thanks.
சரி சரி ஓகே சாப்பிட்டுட்டு வா. இன்வெகேஷன் சாங்கு அதை வச்சுருக்கேன், ப்ளே பண்ணவா? என்ன பண்ணுறது? முதல்ல கேட்டுக்குவா. சரி சரி ஓகே. மேம் குட் மார்னிங் மேம். மேம் இன்வொகேஷன் சாங் ப்ளே பண்ணுங்களா மேம்? சரிங்க மேம் ஓகே. ஆ ஆ சரி வந்துடுங்க மேம், சாப்பிட்டேன். ஓகே தேங்க்யூ மேம். கேட்ட இன்வொகேஷன் சாங் வேணாமா? நேற்று என்ன பண்ணீங்களோ அதே மாதிரி பண்ணிவிடுங்க. சரி ஓகே. சரிம்மா சாரி. சரி தேங்க்ஸ். ஓகே ஓகே.
Madam, I think it's getting right.
Good morning to all, sir. 9:30 only started, sir, program.
Good morning.
Good morning, sir. Yes, it's true, sir. Thank you. Good morning, ma'am.
Good morning, ma'am. Good morning, sir.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good morning. This is Radha, ma'am. I'm Muhammad Rafi. I hope you understand.
How are you, sir? How are you?
Fine. Good morning.
Sir, after a long time, I'm seeing you, sir. Rafi, sir.
Yeah.
Around
I'm
4 years
here,
back.
Yeah, 2 years back. I'm now in Coimbatore Marine College.
10th, Marine
Coimbatore
College.
Marine College, CMC.
Very good, sir. Very good, sir. Nice to hear him.
Shanti has asked me to join.
Thank you, sir. Thank you for joining, sir.
Thank you.
Good morning to all. It's an honor to welcome all the participants who have gathered here. This is Sindhuja welcoming you all on behalf of the Department of Marine Engineering, Amet, deemed to be university for the 5-day faculty development program. Now I invite Dr. P. Shanti for her welcome address.
A very good morning to everyone. This is Dr. Shanti, coordinator of the program. On behalf of the Department of Marine Engineering, Amet, deemed to be university, it gives me a great pleasure to welcome all of you this morning to the 5-day faculty development program on future trends in shipping. I welcome our respected resource persons, beloved principal, dean academics, HODs and faculty members of the various departments, participants from other institutions and my dear students. This program has been designed with lectures and examples to provide skills, encourage participation and exchange informations. Today's lecture of this program is given by two speakers. They are Chief Engineer Ramalingam Govindasamy, Disney Cruise Ship as Dry Dock Superintendent Engineer, USA, and Dr. Vijay Rajeshwaran sir, Managing Director, VI Microsystem, Chennai. Now I hand it to Mic over to Ms. Sindhuja, Assistant Professor.
Thank you, madam. Now I request Professor and Dean Academic Dr. T. Sasilata to give her presidential address.
Respected Principal of DGS courses, Professor Bhupati Bhaskaran, distinguished guest speaker, Chief Engineer Ramalingam Govindasamy, respected coordinators of this event, faculty of Marine Engineering Department, faculty members of other departments, and other participants who have joined from various organizations. Very good morning to all. Really, it gives me immense pleasure to address this gathering. I take this opportunity to extend my gratitude to our Amet management, Vice Chancellor, Registrar, Joint Registrar, Principal of DGS courses to support and encourage our faculty to organize this 5 days faculty development program on future trends in shipping. I thank the coordinators for identifying this title of discussion, which is the future trends in shipping. This title speaks a lot in shipping industries. You know, International Association of Maritime Universities encourage all the member universities and colleges, of course all maritime universities, to pursue research in future trends in shipping. In modern era, we have experienced a strong trend towards greater professionalization to everyone, professional competency standards intended to enhance and support the student community. So at this juncture, I would like to extend my appreciation to the coordinators for choosing right resource persons for the 5 days FDP on future trends in shipping. There are a number of resource persons, not only from shipping industries, but also from other industries. Even today, we have the guest speaker from USA, Chief Engineer Ramalingam Govindasamy is available here. He is going to share his experience and expertise in safety and efficiency, leveraging new technologies and digitization in shipping. So in shipping industries, there are number of things to be explored by the young and energetic faculty members and the students of our Marine Engineering Department. So I congratulate the organizers, and I would like to extend my warm welcome to all the participants in this call. Wish you all the best. Thank you.
Thank you, madam. Now I request our principal, Professor Bhupati Bhaskaran, to render his felicitation address.
Good morning to one and all. I hope I am audible now. Madam, am I audible?
Yes, sir.
Okay. Good morning to one and all. I first and the foremost thank our Chancellor Sir, Vice Chancellor Sir, Pro Chancellor, Pro Vice Chancellor, Registrar, and our, above all, Dean Academics, our Dr. Sashlata Madam, for giving us this opportunity, this platform, and bringing us together. The first and the foremost thing is, in this COVID situation, we are all isolated, and day by day, it looks like, is this the world that we are going to live in the future? But it's not so. Madam, with a great effort, under the guidance of our Chancellor and the Vice Chancellor and so on, has given us this platform. Again, I say, I thank Madam first for this, meeting organization, the future trends, on a topic called future trends. Now I invite our faculties, well-experienced faculties are there in this panel, and also not in the panel, of the panel too, to listen to the speakers and to learn a lot. Every day is a learning platform. Maybe we as a faculties or we have been away from shipping industry maybe from 30 years back or 20 years back or whatever may be. The new trends which has come in that we are going to hear, and we are going to see the future. What is it that the future is going to come up with in shipping industry? We are going to hear from our speakers. Now, I also thank our cadets who have taken deep interest. I've seen the registration count, and now it has gone beyond, the 100, where it will not, this system will not cope up, and it's gone to YouTube usage system. And I'm very sure about 800 of them I've seen the registration, I believe, and at least about 700 or 500 to 700 would attend this program, the 5 days program, and be benefited through this. Now, knowledge is wealth. I tell you, knowledge is wealth. Even today, early morning, I just switched on some, YouTube links just to see how it is, and I saw something wonderful coming out of it. We have a lot to learn. Please keep your minds, cadets, keep your minds open. And every word that is spoken in this, what do you call, the program of 10 chief engineers are going, 10 industrial specialists. I don't call them only chief engineers, they are industrial specialists also involved. Everyone are going to share their views. Sir, now I welcome on behalf of Amet University Marine Engineering Department all our speakers, and I hope we are all expecting the level best from you, sir. I hope you will deliver and keep us energized throughout the program. Now, with this, I hand over the mic to the organizing team, Dr. Shanti Madam and Mrs. Sindhuja Madam. Thank you.
Thank you, sir.
Thank you, sir. I have immense pleasure to introduce the chief guest, Chief Engineer Ramalingam, USP. Chief Engineer Ramalingam completed his BS in Marine Engineering in 2005 and joined as TME with Varun Shipping. After passing Class 4, he worked for the Fleet Management Company as Port Engineer in 2007. He became a third engineer in 2009 while working for Disney Cruise Line. He was promoted as second engineer in 2012 and first engineer in 2015 after accomplishing all the assignments set forth by his employer, Disney Cruise Line. He became a chief engineer in 2018. In addition to sailing, he has also worked as lecturer in a few colleges in India and UK, and has published technical articles during his tenure. He is currently working as dry dock superintendent engineer. With a small introductions about him, I would like to call upon Chief Engineer Ramalingam to take over this session.
Welcome, sir. Dr. Ramalingam, sir.
Madam, you please check whether he is available in the call.
Yes, sir. Yes, ma'am. Sir, join, sir. Hello, you are inside in the link? Yes, sir. Yes, ma'am, keep joining, ma'am. Yes, sir. Okay, sir. Once. Okay. Okay, 1 second, sir. So some of the person full meeting full and comic showing 100 reached, so keep trying that.
Ma'am, you please wait. Please wait, ma'am. I will accommodate him. Okay?
Yes, ma'am. meeting. Sir, our faculty, please, just three of them, please. Sir, your Ram Govindasamy is coming, sir. Okay, sir. Okay, sir. Admitted, sir. Yes. Okay, thank you, sir. Thank you, sir. Yes, ma'am, coming, ma'am.
Morning, sir. Welcome, sir.
Good morning, sir. Thank you.
Good morning,
Good
sir.
to see you
Welcome.
here.
Welcome, sir. Welcome.
Thank you,
We
thank
are
you,
all
thank you.
waiting
Thank
to
you.
hear you, sir, now.
Thank you, sir. Look, like your new look, sir.
Thank you, sir. Thank you. Thank you.
Can we start or we are waiting for somebody, sir?
No, we can start, sir. I think we have finished the inaugural part. Actually, somehow we missed you.
Okay.
Yes, sir. So your
Okay.
introduction is also given by Dr. Shanti Madam. Shanti Madam, Sindhuja Madam, can you just
Okay.
give the introduction just 2 minutes so it's
Okay,
easier?
sir. Okay.
Yeah.
Okay, sir. Okay, sir.
No, not a problem.
I have immense pleasure to introduce the chief guest, Chief Engineer Ramalingam. Chief Engineer Ramalingam completed his BS in Marine Engineering in 2005 and joined the TME with Varun Shipping. After passing Class 4, he worked for Fleet Management Company as fourth engineer in 2007. He became a third engineer in 2009 while working for Disney Cruise Line. He was promoted as second engineer in 2012 and first engineer in 2015 after accomplishing all the assignments set forth by his employer, Disney Cruise Line. He became a chief engineer in 2018. In addition to sailing, he has also worked as lecturer in a few colleges in India and UK and has published technical articles during his tenure. He is currently working as dry dock superintendent engineer. With the small introductions about him, I would like to call upon Chief Engineer Ramalingam to take over this session.
Thank you, ma'am. That was not very brief. It was elaborate. Anyway, that's all about me. Thank you so much.
Thank you.
Yeah, it makes it easier. I don't have to, explain so much about myself. So I get into our presentation straight away. And first of all, I would like to thank, the Amet leadership and Principal Sir, Bhupati Bhaskaran Sir, for this great opportunity. And I'm really overwhelmed. Right now I'm sailing. Behind me you see it's a ship cabin. Right now we are in Bahamas, right in the middle of the Bermuda Triangle actually. So hopefully the connection stays for some time, without getting disconnected. Right. Let me start some presentation here. Can some of you please confirm if you can see my screen?
Yes, sir. We can
Yes,
see your
sir.
screen, sir.
Yes.
Okay. Thank you. I just, I ask you to expand this view, so you get to see all my animations that I've made with all the information. Okay, let's straight away get into the topic. I know there are a lot of other people after me who have to deliver their speech. Right. The topic given to me was safety and efficiency, leveraging new technologies and digitalization in shipping. I should say that the topic I have chosen. So these are the two topics that I'm going to talk about, and both are kind of similar topics. The safety and efficiency with new technology and digitalization both goes hand in hand. So I really aim at giving you all what I have seen in the recent past, and as a superintendent, what I have seen in other ships on new builds. So I hope this presentation is helpful to you all. Okay, God said to Noah, "Make yourself an ark of gopher wood, make rooms in the ark, and cover it inside and outside with pitch. This is how you are to make it. The length of the ark 300 cubits, its breadth 50 cubits, and its height 30 cubits." You must be wondering, yes, this is from the Bible, right? God said to Noah to make an ark. I think this is the first ever documented ship. And what you see on the screen is a imaginary view of ark that Noah made. And ever since, the shipping continued to evolve. So it is about the technological advancements. So things keep moving, and especially in the last 2 decades, things moving at very high pace. God created this world, and we seafaring community simply moved it around. Yes, we do a lot of stuff. Right. Today's marine transportation systems are an integral part of maritime trade, functioning at high efficiency. However, shipping has tenaciously clung to its traditional roots until the last decade or so. I think a lot of senior people here would accept with me when I joined as a fifth engineer. My chief engineer still refused to write emails, and he simply wrote it in a paper and posted it, and he waited for the reply through the post itself, from the superintendent engineers. So this was the technology. Technology was often considered as somewhat a liability instead of an asset, but it is definitely an asset. Right. Overview of the various technological advancements in the maritime industry. There are a lot of things we can talk about, but I wanted to categorize it to 4 main aspects or topics. One is fire systems, second one is power production, third one is navigation, and fourth one is communication. Sirs, can you all confirm I'm still here, audible to you?
Yes, sir, very much audible. No problem.
Thank you, sir. Thank you. Thank you, sir. Thank you. I request Shanti, Dr. Shanti, madam, to give me a call on WhatsApp if at all I get disconnected. Thank you.
Sure, sir.
Thank you. Thank you. Thank you. Thank you. Thank you. Okay. Why did I take these 4 topics? Because these 4 topics cover 85% of the output a ship would have. These 4 factors govern the complete technical operation of a ship. So safety system, power production, navigation, and communication. These are the 4 main topics that we are going to see and elaborate today. Let us see the technical advancements in safety systems first. To make it simple, I have divided the safety systems into 4. What we really aim at as seafarers is it has to prevent us from any risk, it has to detect the risk at the right time and alert us in the right way, right moment, and right place. And also, once the risk starts, it has to contain the danger, it has to contain the risk. This is what we expect from a safety system. So what are all the technological advancements in ship in the last decade that has taken place in safety system? Let's go ahead and see. The first one we are going to see is detection. Detection is nothing but the sensing part of any safety system. The best sensor ever made in the world, which cannot be replaced, is human, the human itself. We have eyes, nose, ears, skin for touch and feel. But they say, yes, dogs can smell better and snakes can hear the least vibration and all this. But I'm not going to get into, too much into, details, but human has a differentiation. Whatever data the human is able to sense, is able to process it. He has got the best microprocessor as well. So the recent modifications or the recent developments aimed at bringing the sensing elements close to a human. Let's see how. The first thing I would talk about detection, as you can see on the screen, that's a swan, which is Hamsa or Annaparavai in Tamil. They say there is a belief that this can separate milk from the mixture of water and milk, right? I'm not getting into the belief about this bird, but what I am quoting here be of such quality, right? So a sensor should have the best and the better sensing capabilities. That is very important. In an engine room or in a shipboard environment, there will be a lot of disturbances, harmonics, noise. The sensor has to catch the right thing which it is intended to. So a sensor of any kind is very crucial in automation. Development of such sensing elements and logic using microprocessors have improved detection technology to an unbelievable level. Okay, sorry. Okay, the first thing is the video detection technology, which is nearly a human eye, right? So, like I said, all these technological advancements in safety system, especially with the sensing, is trying to be as close as it is possible to a human sensors. So, to replace an human eye, which is not possible, but still they are coming as close as they can, which is a video detection technology. Just think of a CCTV camera that we have at home, streets, colleges. One proud thing that I come across is Chennai is the best in the country, which has the best visibility in terms of CCTV camera. So CCTV camera, just think about it. They just capture the data. What if they start to think what is in the video that is captured? What if they start to process the information that they capture? That's what they are talking about here. You can see this in the image. What you see here, it's a land-based power plant where there is a cloud of. Let me get the laser pen. Yes, there is a cloud of fume from a overheated bearing shell, right? But the bearing is still functioning. There is absolutely nothing has gone wrong, but the bearing is starting to overheat and the fumes are being emanated. The video, the CCTV camera, is not only capturing it, but is also thinking something is going wrong. You can see a blue outlined cloud is being captured and it is already informed, alerted to the engineer. So here we not only saved this place from a major fire accident, but also saved a lot of cost as on the property. You know, even the bearing, just the bearing can be replaced and the whole system can be salvaged. If not, the whole thing there would go into waste, right? A sensing flame and spread of smoke. I've just expanded this image. What you see is a very small fire here, and there is a cloud of smoke which the video detection technology has also already captured and it is already alerted. So the next thing, one of the major reasons for fire accidents, especially these days with high pressure fuel injections, with common rail engines, the pressure of the engine fuel injection is close to 9,950, close to 2,000 bar. We can't afford to have any leak at all, but still we have, materials, they keep failing. And these are the major causes of fire. All our boiler suits have a reflective tape these days, but it happened in a cruise ship where a high pressure fuel line leaked into high temperature exhaust manifold, and the fire started and a lot of people died. After that, Solas brought the reflective tapes on our boiler suits and any suits that we wear in the engine room. So this is definitely a boon. It is something that we are blessed, in this era with this kind of technologies. This technology can immediately catch at the fume itself before the high pressure and already alarmed. And this is the place where we tested in our ship. What you see here is one of our ships, and we have tried to simulate smoke in a dark environment, and the cameras were still able to capture. So these are the things that I want to bring it to you all, that the sensor, which I said is the critical element of a safety system, and a simple CCTV camera has now come up with microprocessors, and they start to think what's happening on the video. Not only capture, record, but also start to think, right? The next one is smell detection technology, nearly a human nose, right? Why smell? We already have video. Why smell? Most of the seafarers, all seniors here, would agree with me that anything that has to go wrong starts with the smell. In engine room, we first smell something wrong, and then things follow after. So smell detection technology smells and finds out the risk or error well in advance. So these SDT sensors use its unique capacity to smell the atmosphere around and around in the atmosphere around, and process it with the preset smells such as hydrocarbon vapors, paints, solvents, aerosols, even steam. Smell of steam is also detected at a very early stage by this smell detection technology. Well, replacements to human sensing capabilities, ladies and gentlemen, I don't know. I'm not too sure if we can replace human sensing capabilities. I don't think so. But we are trying to go the technology is trying to go as close as it is possible to the sensing element. Well, next, let's go into alerting. Alerting is nothing but notification element. Like on your mobile, say you're getting a call. If you don't get a notification, you're going to miss the call. So alerting has to happen to let us know. But alerting has to happen at the right moment, right place, right quantum, and in the right degree. If we are going to be alerted for every thing which is not really serious, that's bad. But if you are going to miss even one serious one, it is going to be bad as well. So the safety system alerting has to be improved. Technology has gone into that as well. Let me explain you. Okay, alerting, as you can see the animation on the screen, there are physical sensors which we talked about. There are imaging sensors which we have talked about, and operational data. Operational data is like pressures, temperatures, wind, speed, position. So these are all operational data of a ship, and then something called the past history which is already there. So what happens? There is a sensor, physical sensor, like a temperature measuring probe, which is there. Imaging sensor, a CCTV camera. Operational data, yes, we have, and past history we have. But an alert system should be able to read all of them, collate the data, analyze, and produce an alert when it is necessary at the right time. Expect the unexpected, right? So what am I referring to an alert system to be here is a proactive system, which has to tell us in advance that there is an error that is going to happen. Very interesting situation that I have come across. To make it, let me make it simple. I work for a cruise line, and most of them are new ships, and like cargo ships, cruise line, 4,000 to 5 most modern. Out of 4 ships that we have, one of the ship I had a very interesting incident that I'm going to present it to you next. One day, I received an alert message that DG2 oil consumption per running hour is higher than other engines, and also it said possible leak from lube oil purifier number 2. Right. So this message shows us that this system, alert system, knows that DG2 oil consumption per running hours. So it has the running hours. It knows the running hours of the engine is higher than other engines, which means not only it knows the running hours of the other engines, but also it knows the consumption of the other engine, and possible leak from lube oil purifier number 2. So even it is telling you where can be a mistake, where can be the error happening. Let's see what happened. Let me tell you what happened after that. Alert triggered that the consumption is higher than other engines. Further, we investigated. We found that the lube oil purifier is leaking just 2 to 3 liters, which is otherwise unnoticeable. As the senior engineers and senior operators here would accept with me, that 2 to 3 liters is kind of, we don't even, not that we don't want to bother, but we cannot. So 2 to 3 liters, which is otherwise unnoticeable, if not this smart intelligent system didn't pick it up. And then the corrective action, very simple. The purifier was opened and we rectified it, and the 4th engineer assembled it. Leak stopped. Volume of oil wasted so far is 2 to 3 liters per hour, which is 72 liters per day, which is 2,160 liters per month. And what does that imply? That implies cost of 1 liter of this lube oil is $1.48. So cost saved per month is $3,197. For a ship operator, $3,197 is peanuts. To be honest, we don't really care. Not that we don't want to care, but there are a lot of other things to worry about. But don't forget, it is just one alarm. This smart security safety system has saved, just with one alarm, $3,197. Then we wanted to understand the logic. What happened? How it was able to tell us that it is higher than the other engines, and also it can be leaking into purifier by purifier number 2. Let's see that. Okay, this system has access to bunker quality. So it knows how much fuel we purchased. And it also knows that it is little bit slightly higher than in the last 6 months, which is a half yearly benchmark value is slightly higher than usual, right? And then it also knows the DG2 consumption, which is also slightly higher. These are all separate elements. Somebody's interrupting?
No, sir. Go ahead, sir. No, sir. You can go ahead.
Okay. Thank you. Okay. So DG2 consumption was high, so these are all individual elements, which is not connected, right? Bunker quantity, it is in a different folder. We don't know. That is separate. DG2 consumption, yes, it is a separate thing. Nobody knows. Third thing, sludge tank filling is slightly higher than its usual value compared to weekly, monthly, even quarterly and annual values. That is a separate thing. The system knows. And lube oil analysis report says that the oil quality is like new. DG2 lube oil analysis report says the oil feels very fresh, like a new oil. Now we have 4 different symptoms happening in one engine room. Now the smart intelligent system uses its, it doesn't have brain, but it uses the logic that we human have input. Finally, it aggregates and finds out that as per the logic set by the user, it knows the bunkering quantity increased, DG2 consumption is increasing, sludge tank filling pattern is varying, increasing, constant increase. Lube oil analysis report says the lube oil looks like new, whereas other engines have some variations. So immediately it triggers the alarm that DG2 per running hour is very high than the other engines. So this is one of the beauty of the recent developments in safety systems. This is what I was talking about. Alert in the right time, right quantum, right place, in the right moment. Right. Next, we talk about containment, restricting element. Again, I want to quote a very interesting information with you. When I worked for a yacht company, it's purchased by one of the richest man in Europe. It was a yacht, and I had a 3 months contract, and it was pretty new. Even the owner didn't have any clue about the yacht at all.
Yes,
we had a fire once in deck 3. So we, as soon as there is a fire, we, as seafarers, our heart starts pounding much faster than usual, and we immediately start reacting. Forget the years of experience, we still get panicked because we don't want anything to go wrong, and we don't want anybody to get hurt, or we don't want loss to the environment or to the owner. All that thing goes in, especially if you are a captain or a chief engineer, it goes into your mind, right? So there was a fire in deck 3. We were all in deck 3, donning the suits, trying to rig the hose, fight the fire, plan how to stop the fire. Suddenly we have an alarm on deck 4 and deck 2. There is a flooding. So there is a flooding happening in deck above and deck below. What's happening? So the captain said, Bada sir, can you have a look while the team is trying to fight? Let's have a look what's happening. It's a small boat, So I went there and I saw the deck above. There was the sprinklers, like this. They were like high fox sprinklers, and they were on. And deck 3, it was on. All the heads were on, and I found the deck 4. I mean the deck one deck below. Alternative sprinkler head was on. I thought, there is a fire, and definitely some wires might have melted and short circuited. So something wrong is going on. What I did, that was an error from our side as well. We decided to close the valves of the sprinklers, and we continued to fight the fire. About an hour and a half, we fire successfully quenched, and the owner was happy, and the Coast Guard was happy. Everybody was happy. But we did a biggest mistake. When we start to learn the safety system containment, that is restricting element, is really a smart logic behind it. Fire in deck 3, the fire, it is measuring the quantum, it is measuring the temperature, it is measuring the radiation, rate of increase of temperature. So it knows that the temperature at deck above is going to increase. So it automatically starts pouring the water through the sprinklers. Whereas the deck below, the quantum is not so much. That's why it smartly activated the alternate sprinkler heads. So that was a stunning moment for us. That's a yard boats usually come with the latest technology that they have, and that was a surprise thing to us that sometimes these technologies even overtake human.
But sir,
Forget your experience, I thought I was the most experienced man, whatever, but then this technology makes you feel very small. Containment, that's what I'm talking about. Let's see what do I mean by containment. We have to contain the loss or risk. Well, the containment happens after the risk has actually started.
Okay.
So the first element in containing is to assess the risk. Exactly the fire that I referred to in the yard boat, the safety systems start to measure where is the fire, how much is the fire, what is the surrounding, is it a fuel tank, is it a burnable combustible material, or it is an insulated material, how is the insulation. So with the architecture of the ship, of the boat, it is able to assess the risk. And then the next part is going to be project the risk, like we see in cricket matches. In a 20-over match, after 5 overs we project for the next 20 overs how the match is going to go. Similarly, this system is projecting the risk for the next few hours. It is thinking what is going to happen. And then comes the historical data. Human, we often tend to forget things, but the machines remember the historical data. So it also compares the historical data. Historical data doesn't have to be from that particular ship, but also from different ships, sister ships, other ships in the fleet. So all these three data is, taken, analyzed. Finally, the safety system with the modern integration, with the technological advancement, provides ideas. Like I said, in spite of experience, I've seen many, senior great seafarers kind of panicking because of the fear that I told you, that we don't want to lose any lives, right? And we cannot forget ourselves in our the coming life. So we don't want any life to be lost. And then it goes to environment, then it goes to the property, then it goes to the resting may stop working. But we expect these systems, they are machines, they never panic. So they have a calm mind to process this. Imagine it's processed by a microprocessor. The processing is so quick. The calculation is so quick. Referring to historical data is so quick. And also you get ideas to attack or to prevent a risk or an error or a fire is very fast. So that's what I'm talking about, containing the loss. And the recent modern integration in fire system does include this kind of containment system. Right. That's about safety systems, ladies and gentlemen. I don't want to drag further. Those are the recent developments that we are seeing right now. And the next thing is about technological advancements in power production. Power in any ship is just fuel. There is no other power. Even if there is a stored energy in the batteries, it is still produced by the fuel energy. So the only single source of power is fuel, right? So this fuel has to be converted into electrical energy in generators, propulsion energy in main engines, heat energy in boilers, and pneumatic and hydraulic energy in compressors and different pumps. So fuel energy into different forms of energy, that's what we convert, and the consumption of fuel is enormous. Ship is the only mode of transport which consumes so much of fuel. For the size and quantity, it is much lesser. Car consumes much more. For the useful work it does. Still, we can proudly say, as seafarer or a seafaring community, that we spend much more less fuel than for the good work that we do to the rest of the world. Right? Like I said, God just created, but we have all the pain of moving it around. Seafarers, I'm very proud about it. Right, the fuel energy is converted into all these energies. but the transformation of this energy into different energy, the process has to be simpler. And with the latest modifications and the latest advancements, this has become very, very simpler. I wouldn't say much simpler, but definitely simpler. Let me explain you. When I was 7 years old, I still remember my father had a TVS 50 moped, which is they say pride of Tamil Nadu. So we had that TVS 50, and I still remember him boasting to my neighbor uncle that his TVS 50 gives him 30 kilometers per liter. That was the time. But right now, the same TVS 50, I heard it gives 60 liters. There are many other bikes first. What has happened here? It just goes by, the fuel price is increasing. How come the work done is increasing? So the conversion process, there is so much of technology advancements and science thoughts put behind, and the conversion process has made simpler. Hence the output has increased. And that's what our in maritime field also the latest advancements has put in. Okay. How is it? I would first bring electronic engines to you, ladies and gentlemen. Electronic engine is going to be the future, right? Right now we have about 7 ships, 4 ships already built, and 3 more ships coming on our way. So the last 2 ships and the 3 ships which are coming, so it's going to be 5 ships out of 7 in a cruise line, modern cruise line, all electronic engines. Trust me, it is all going to be electronic engines, even in cargo industry. Why electronic engines? Like I said, fuel energy into useful energy. The conversion process is much more simpler, therefore the efficiency increases. Electronic engines have variable timing, electronic injection. First thing with electronic engines, I would like to bring to your notice, the size has reduced. There is no more camshafts. Even your cars, Ambassador car had a big engine. You remember the width of the Ambassador car is so much. It had a very big engine. These days engines come much smaller, not even 1/4 of the size that the old Ambassador cars had. So what happened? The process, the technology has just marvelously been put in to reduce the size. So the first thing that has happened to electronic engine is to reduce its size. Obviously, reduce physical components. By reducing physical components, it's always there is a inertia force, lackness. There's a lot of other factors like inertia. That kind of prevents the physical components to move. So there is always a lag, and due to which the efficiency is also very less. Whereas electronic engines has removed a lot of physical components and made it a PCB which just looks 10 centimeter by 10 centimeter size box that governs all that job that these camshafts, the push rods, rocker arms, all these things are doing. So electronic engines is the way forward. Even sometimes, I even like principal sir once asked me to come up with new curriculum for the students. So I request the great universities like Amet also, we should all think about having more and more about electronic engines in our curriculum, piston pipes, and Indian mariners, we are very strong. Our basic is so strong, so we are able to survive. But I see many different countries have very poor knowledge in this aspect. Right. Let's go into the next topic. Is engineered materials. Oh, this is amazing stuff, which I am thrilled. There is a question I still remember when in our engineering we asked them, draw a gear pump and mark the parts and write the materials. Ladies and gentlemen, let me tell you, there can be no more such questions. Modern days, the materials are definitely not known to anybody. It's a trade secret of a manufacturer. They use the computer technology to mix various metals and make alloys, which they do not reveal exactly what is the metal. There is no more metal, ladies and gentlemen. We cannot name the parts. We can name the parts, we cannot write the materials of any physical component henceforth, because there is so much of mixes, alloys, that is being produced kind of engineered metals. It is not anymore natural metal, it's engineered metal. It can be metallic, ceramic, polymeric, and composite materials to achieve capabilities such as strength, toughness, durability. But these are all function specific. If a gear pump, is it going to be used for fuel? Different metal. Is it going to be used for lube oil? Different metal. Is it going to be used for high temperature fluid? Different metal composition. So,
Yes,
gear
sir,
pump,
you have to join
just
now
for an
with the
example,
faculty. You
think
have
of
to put, sir. After that
connecting
only I
rod,
have to admit. The
crankshaft,
students also coming. That
piston
will,
rings. Everything in this world,
yes, sir. You
seafaring world,
come and
has
join.
changed.
After your
Tremendous
name,
change
put
in
in
that.
faculty.
Like me as an engineer, chief engineer,
After that
the
only I have
superintendent
to
would ask
admit.
me, can you please refer the materials?
You
No,
have
it's
to
not
put your
possible.
name,
Even the
where is
manufacturer
it?
doesn't
Join,
release
join
because
with
it is a
Google
trade secret.
Meet.
Because they don't want to lose. They produce material, compositions,
sir,
they
now
work
thank
so
you.
hard, do R&Ds to bring out such a composition that is going to prolong the life of their own products. Next, propulsion and powering. I'll tell you something very interesting. I've been to the shipyard last week, and what we witnessed is the ship that we are building right now does not have a main engine. I'm not joking or I'm not exaggerating. Does not have a main engine. Does not have a propeller shaft. Does not have a propeller. But still, the ship will make much more fast speed than any other ship. It is a podded construction, podded propulsion, ladies and gentlemen. The podded propulsion, podded. So it is a motor that is under the water, right? There is no rudder. There is no need of rudder. The motor itself can turn 360 degrees. The motor, which is under the water, also it has a propeller attached to it. So if you want to turn the ship, just turn the motor itself. The propeller itself turns its aperture. So also there is no thrusters. Like we used to have a thrusters, no need of thrusters. So just imagine, just in a period of 10 years, just in a decade, we have so much difference in propulsion power, right? Propulsion system, that is with the product system. Also these days, the engines are made to use dual fuel and also use solar, wind and wave energies. Whatever energy that you can gain from these renewable sources can be accommodated inside the engine. So this is the, this is one of the major developments that I have seen in propulsion and powering. Okay. The next one is going to be advanced. This keeps on going. This keeps going on. It's a very healthy argument that we used to have when we were young. Once I said to a captain, when I was young, even I was arguing with the captain that we are much more smarter and all this stuff. That captain said, Ram, navigation is an art. Not everybody can do it. But now I really agree to that experienced captain. Yes, it is an art. When there was no GPS, when there was no EGDIS, there was no radars. How did they calculate? How did they measure the position? You have to take the lunar distance and attitude of the particular star, and then measure the distance between the star and the moon, and then the angle at which you are viewing the moon. All these things have to be calculated to plot the position. Such was the case with navigation technology. Not anymore. Right now, the ships are installed with GPS navigation, ladies and gentlemen. The GPS is able to coordinate with the satellites and able to give you the exact position within a second. You have the position of your current position, latitude and longitude. So with this, the navigation also has transformed tremendously into a new era, but not as much you would expect, because like they say, the ship engine room is unmanned, but not the bridge. They say that the bridge cannot be unmanned because the human sensing capabilities and human decision making cannot be replaced. So ships are still not in unmanned position yet, but these GPS navigations and other things that we are going to see further have definitely changed the way we have been navigating the ships around the world. What they are. Automatic identification system. this is one of the marvel. This is one of the marvel that has come in the last 2 decades, I would say, or I'm seeing more in the last 2 decades. AIS system. So a ship is somewhere in some of the polar region, let's say, and it does not have any communication to the land or close to any land. Let's say there is a flight crossing over. The ship transmits its position to the flight, and the flight transmits that particular ship's position to the land-based identification system. So the whole world has a visibility. Like I said, the Chennai has the best visibility in terms of CCTV cameras. Right now, even the oceans have better visibility. We cannot afford to lose any of the ships. We will not lose track of any ships with this AIS system. AIS not only helps identify the location, but also it is one of the primary method of collision avoidance for water transport, ladies and gentlemen. So with AIS and GPS, imagine how much of collisions which would have consumed so much life and property and loss to the environment, all have been eradicated with this kind of inventions. The next thing is ECDIS. Do you remember? I'm sure the senior people here would remember the second officer doing 12 to 4 watch. Puts his head down and never sees up because he's so busy plotting the route maps on a physical publication with his pen and pencil and eraser. He makes a mistake, correction on all this stuff. But ECDIS is a boon. Electronic short display and information system. It is so easy. Voyage planning does in 3 seconds. Weather routing, absolutely no problem. The weather routing is something that we really have to consider, because the weather keep changing time to time, and with ECDIS, this update comes within seconds, and the ship is able to safely navigate away from such catastrophes. Okay, the advantage of virtual navigation aids that we discussed is that they can be easily installed and they have low maintenance. At the same time, they can be tampered very easily. Hacking, like computer hacking. So we have to be very careful with that. That's why we are still not fully relying on ECDIS. We are still using the paper charts. Autonomous systems. This is the future, which is still it's not discussed much about it. But autonomous system, as you see on the screen, we are aiming to reduce manpower on board. Have the manpower in the land and reduce the manpower on board. How can we afford that? There will be a station in the land, and there will be a station close to the land in the sea, and there will be autonomous airborne vehicles that will be going around in the ocean, and then we have autonomous underwater vehicles, submarines, that will be going around. So these all have kind of communication with them, that helps control the ships from the land-based entity. So autonomous ships is not a possibility yet, but definitely it will be in the next decade to come. The last one that we are going to see is the communication. Okay, marine communication involves ship-to-ship communication and ship-to-shore communication. Over the years, the ways in which seamen communicate has changed drastically. What do I mean by communication? Is it just the phone calls that we make home? No, it is the data that has to be transferred between ship to shore, between ships to ships and ships to office, shore to shore, and then the final results goes from shore to ship. So all these data transfers has to happen same like how we do it on the shore. So this has taken, trust me, ships are these days installed with 5G technology. Those were the days when we have to go to the bridge to make a phone call to home. It is not anymore. Right now I'm sitting and presenting, I'm doing a presentation from my cabin, from my personal gadget. So technology definitely has improved so much that the things have made simpler. Okay, back in the day, semaphores and flags were primarily used, right? Semaphores is still used in Indian Railway, where you can see on the left side of the screen, these are like, the signals that we call, right? They're called semaphores. and these were used earlier in the ships, and then the flags were used for communication. Those days are gone. Things have changed in the aspect of communication as well. E-navigation. Let me quickly. I'm going to wind it up soon. E-navigation is the thing that IMO is developing. E-navigation it facilitates the greater information and data exchange between ships. It reduces the margin of human error and failure by implementing a better functioning program consisting navigational tools and electronics. Evolution of GMDSS. Oh, this is something that we should know. So many collisions have been avoided and so many distressed people have been salvaged and the lives have been saved and properties saved and marine environment saved. I don't want to reiterate global maritime distress and safety systems. This is definitely a boon to the human community. GMDSS is one of the best so far in terms of distress system, that any ship in distress is able to get identified and salvaged on the right time by the person who is very close to it. Those days have gone like Titanic, ladies and gentlemen. These days, distress, yes, distress is something that we cannot avoid, but distress has become easy to handle these days with advancements in technological advancements. Okay, the final thing would be Arctic communication. Like, we can even reach the moon, we can even reach the Mars and communicate to the rovers there, but reaching Arctic has been a challenge for the humankind for so long, but not anymore. Reaching from Beijing to San Francisco is just 7 to 11 days, depending on the speed of the ship and the quantum of the ice that they have. So Arctic has opened a new era. Arctic shipping is going to set completely a different scenario to the world shipping, and communication even in these polar region has become so effective with the advancement in communication technology. Right. With that, ladies and gentlemen, I hope I was able to bring you some of the latest advancements that I have seen in my life and I've read. Is there any questions to you? Any questions to me?
Audience, now is the time where you can ask questions to sir and get your doubts cleared.
Good morning, sir. This is Faculty Amet. Can you enlighten more on? Yeah, good morning, sir. This is Faculty here, also in Marina. Yeah. Can you enlighten us more on electronic engines? Very interesting. Can you enlighten us more on electronic engines?
Okay, electronic engines, sir. Yeah, it's a very interesting topic. Yes, electronic engines, not only in ships or even in cars these days, are electronically controlled engine. Even bikes are electronically controlled engine. Let me tell you what happens in an electronic engine. Just think of an older engine. How most of the functions were completely physical, right? Like, we had a crankshaft and then we had a camshaft, which is a massive system. As you're a seafarer, you might have seen it. It is a massive unit. The camshaft itself is such a huge unit. It has so much of mass, and then it has cams rotating on that, and then you have a push rod that controls the opening of inlet valves and opening and closing of inlet and exhaust valves, right? And then to start an engine, there was a distributor, and then the distributor had to be run by a cam, and that cam has to control admission of air into different units to fire. So these are the components that are completely removed by electronic engine. I will tell you how. So now, at the right time, inlet valve has to open at the right degree of crankshaft, and the exhaust valve has to close, or exhaust valve has to open and inlet valve has to close. Before, it was done through the camshaft and push rod and all this stuff. Now they have removed that. So that's a huge mass gone. It is not only reducing weight of the engine, sir, but also it's a huge mass rotating. Think of the inertia forces. Think of the lag that the engine would have had. the timing would never be perfect. In a real world, in a physical engine, we all as chief engineers, we all can say that, I have the best timing on my engine. Trust me, sir, once you come to electronic engine, I'm sorry, I'll have to rethink, these electronic engines are so good. Okay, I'll explain you how this electronic injection happens. So, 15 degrees before, let me not take you so this thing. At certain point, the injection has to happen, right? So for that to happen, the cam has to, the physical cam weighing about so much of mass has to move and push the push rod against the spring, and that will push the valve to open or pump to inject the fuel. These days, things have become very simple, sir. The crankshaft is read by 3 different magnetic pickups, and exactly it knows when that particular angle has reached, right? And then computer says inject fuel now. It is just opening of a small solenoid valve that opens, injects the fuel, and closes. Remember, in a physical injection, you cannot really alter the timing or quantity unless you can set it for the all units. If you have 7 units in a ship, all 7 units can be adjusted at one. But here, if you have 3 injectors in 1 unit, each injector can be controlled. So that is the beauty. What you are controlling here, sir, opening and closing of a valve. How easy it is. Switch on, switch off. Switch on for 10 microseconds, switch on this for 2 microseconds. That's it, sir.
Beautiful.
Yes, sir, go ahead, sir.
And what about engine decarb and all that? Those processes essentially in the maintenance process, decarbing of engines. Any changes in that?
Yes, sir, very much, sir. Again, electronic engines, like I said, they have come up, the complete parts, variable parts, the running gears are made of completely a different elements, a different metals. It is not anymore
Sir,
the metals that we
half
talk about, high
முடிச்சிட்டாரு.
tension steel and all this stuff. It is a metal which we don't know, doesn't reveal
ஒரு
that.
5
So,
நிமிஷத்துல join
with
பண்ண
electronic
வேண்டியா
engines,
இருக்க
what has
சொல்லுங்க.
happened is the life expectancy of every individual component has increased so
ஆமா,
much.
ஒரு 5
Sir, I would
minutes
change an
சொல்லுங்க.
injector in 12,000, say 4,000 hours, right? Right now, I'm changing it every 12,000 hours because there is no physical movement at all, sir. There is no push rod, there is no spring which has to be pushed against, and we would have received the component from a country which sells cheaper, and that would wear out even faster. So all this thing leads to a bad injection, sir. Right now, there is no wear parts. It is just opening and closing of my valve. So starting from here, lot of things have become so smoother. So I would open a normal traditional engine every 12,000 hours, sir. Now up to 36,000 hours, I would do a small maintenance, but decarb not up to 36,000 hours, sir, with the recent MAN engines that I've worked.
Wonderful, sir. Nice to know all that. Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Mr. Ramalingam, I would like to, you are referring to Arctic navigation, Arctic communication. Are you referring to Arctic navigation? The distance
Arctic navigation, yes, sir.
The distance is shortened by maybe a few days. I don't know. You move from Beijing to.
Yes, sir.
Okay, that saves some
Yes, sir.
fuel
Okay,
consumption.
Correct, sir.
Thank you.
Sir, as you understand, when you travel through the poles, the distance is of course shorter, and this has opened up completely a different trend of shipping, sir. There's a lot of research going on, but communication system, it was a challenge with the sub-zero temperatures, but they also have been improved now, sir.
Sir, those days we used to have ice class vessels
Yeah.
No, still that is required, isn't it? The ice class vessels to go
yes,
over.
sir.
Thank you, sir. And dear cadets, anyone from the cadets, you can ask sir a question because sir is now sailing. Remember one thing, we are all in the shore listening to sir, where it's a stable moment. Sir is on a ship now, and sir has put his mighty, willpower to keep up the time of the meeting and so on. Now you know what a mariner is. Dear cadets, now the floor is yours. Please ask sir if you have any doubts. He can get you straight to the pond. Thank you. Dear cadet, come forward. Anyone from the cadet slot?
Sir,
Yeah.
how it is our power electronics, how it is merged to our ship, sir? Nowadays, advanced technology, which technology we have to use, sir?
For which one, ma'am? For ship?
Yes,
You
sir.
mean for the safety systems or for the
Yes,
safety
general,
system,
sir.
madam?
Madam is asking on general point, like safety system as well as the fuel injection and the automatic systems.
Nowadays,
Let's
advanced
Okay.
technology also coming, sir. Fuel system, renewable power
Yes.
energy, similar that. So how it
Yes.
is we have to merge
Yes,
to
ma'am. Ma'am, it is all okay. Microprocessors, which that is a very big topic that we all including me, I have to learn if I have to sustain in this field for the next few years. Right? It is all microprocessors, madam. It is a logical circuit boards made for different aspects to control safety system or injection system. So as a chief engineer, right now I have an MA engine right now in this ship, which is a ME series engine, electronic engine. If something goes wrong, all I can do is to replace a board. I just remove an electronic board like a RAM from a motherboard, throw it and put a new board in there.
Sir,
We don't
சொல்லுங்க.
really know how these electronic systems work. All the cadets out here, gentlemen
யாருக்கு?
and ladies, if we have, let me remind you one thing, guys. Our curriculum is so strong. Learn from the basics, never wrong. But as an extracurricular thing, learn electronics. Sir, how do I learn electronics? Very simple thing. Take a flow chart and read. Learn to read the electronic circuit. That will keep you going forever and forever. That is a very good step already. Right now, if you ask me, I can read a hydraulic circuit. Electronic circuit, still, I'm a big failure because I've never learnt it when I was young. So to all you young guys, I would suggest go ahead, learn the electronic systems, at least to read the circuits.
Yes, sir. Captain Karthik sir had he has raised his hand. Captain sir, welcome, sir.
First of all, my salute to Mr. Ram Govindasamy sir. It's really very interesting.
Thank you,
that
Captain.
you are now on the dynamic platform, ship is moving, and from there you are able to connect to us in a very seamless manner. As a principal, sir,
Yes.
first started the meeting, I thought you were at the comfort of your home. But only when you said that you are sitting and it's your cabin, I couldn't imagine. So all that what you touched upon is very relevant, and practically you demonstrated also how much communication is advanced. And you beautifully you touched upon all the points.
Thank you, sir.
I could see that now, possibly, I don't know what's the time there. It could be a little bit somewhere late night, or I don't know what's the time there now. But I normally during our sailing days we used to see ourselves running around here and there looking after the machinery.
Sir,
But now with all these electronics,
It's about early morning, 1 o'clock, sir. Yeah.
Oh, okay.
Yeah.
First of all, thank you for that.
Life is much more easier, sir. Yeah, thank you, sir.
Thank you. You are contributing your less time to our upgradation of our career. That's very interesting. Since, as you said, now
It's an
the
honor, sir.
now the life is a little what less complicated than earlier, and we can devote our times on
Yes,
more time on aspects of let's say psychological aspects and how to deal with pandemic. What do you think
True, sir.
should be the current things we need to include in the curriculum, and that should be more relevant to make our curriculum more relevant to the current mariners? What could be your suggestions? If I ask you two things that you would suggest that would fortify your
Yes.
curriculum with respect to academic and also with respect to personality.
Right, sir. Let me go first with the academic side, sir. As Principal Sir, Mr. Bhupati also has asked me, we are working on it. The first thing, sir, that we really have to change in our curriculum is to get rid of those traditional stuffs. We're still reading about Wilcock and Babcock's boilers, sir. Even our examiners, to be honest with you, the examiners don't ask you about the actual boilers that we have, and they fail our intelligent students, our cadets. When they go, they fail because these guys have seen a different thing and they have seen decades long old things, sir. So I would say, sir, more into non-traditional engines like electrical propulsion, powdered propulsion is going to be the future, sir. Instead of focusing on the main engine, two-stroke, connecting rod, all that things, sir, that is fine. But we will have to focus on electronic engines, sir. As a chief engineer, I'm not feeling shame, but I will tell you, something goes wrong in my engine, I take Bati sir. Even if it is middle of the night, I call Bati sir, please come. Without him, I don't go down, sir. I don't know, sir. Actually, I only know how to pull the PLC out, but I can put it back. If I trip something, then he will be upset. So that is something that we have to impart, sir. Second thing, sir, from cruise line, 2008, I joined cruise line, sir, with the cadets welfare or personal grooming, sir. One thing with our Indian boys that I would suggest them that the language, first thing is language, etiquette, manners. Not that we are bad, sir. We have the best cultures that I have observed. But when you come to a continental style, things have to be different, sir. So I would tell them, as they are watching a lot of English movies, not only see the beauty of the movie, but also pick up stuff from there. How do they eat? How do they use spoon and fork? How do they talk? Like when I was interviewed, sir, I was thinking in my mind that I look so dark, I'm not even going to be considered. But they don't look on that aspect at all, sir. To groom well, I would ask our cadets, focus on learning your language, improve your language, have a neutral tone. Don't try to talk like an American, but just make sure your pronunciation is good. Your turnaround, wear a proper shirt, your shaving, grooming, and all this stuff. And language and etiquette, manners, learn what is common in a continental style, sir. That is something that I would really tell our students to pick up, sir.
Thank you, sir. That's nice contribution. Thanks again. Cheers and God
Thank you,
bless.
sir.
Have a safe and
Thank you.
paragraphs.
Yeah, Bada
Thank you,
sir.
sir. Thank you.
Sir, excuse me, sir.
Yes.
One student asked a question. How ship without main engine will affect manning?
Okay. See, I kind of exaggerated that point. See, definitely there's a main engine, not the big main engine that we have and a long propulsion shaft we have. Think of a motor, madam. Just think of a motor, electric motor with a shaft and a propeller attached to it. So that motor, I would refer you to podded propulsion. So that motor is put under the water, where the propeller is. Okay, it's outside completely. It's kind of hanging, and it is in a turnable, rotatable aperture. So the motor itself can turn, right? It's an electrical propulsion, madam. That to make it simple, we have generators which are massive. Okay, instead of having one big main engine, we have 5, 6 generators, 7 generators that produce power and supply the power to a motor, and that motor propels the ship, madam. And the motor can turn into 360 degrees, so turning a ship also becomes easier. So definitely we should have a main engine, madam. I was exaggerating that point, yes.
Yes, sir.
Sir, one question now
Yeah.
that you are on the ship. Of course, I can see there is no rolling and pitching. You are absolutely skilled over there. Yeah.
Yes, sir.
One question: what kind of communication system? Of course, GMDSS is mandatory, so you must be having that. Other than that,
Yes,
now we are able to communicate with you on the video as well as audio. What kind of communication system do you have on board? Is it VSAT or Iridium? I mean, just for information's sake.
Yeah, it is. Yeah, I think Iridium is the brand. Yes, we do have. We use Iridium satellites, SatNav system, but the technology is changed, sir. Which even I'm really not so particular about the technology, but it is the same technology that is called 5G back home, the same bandwidth.
Okay.
That's what we are using. Yeah, especially for cruise ships, they have started. It's the same Iridium satellites with SatNav systems that is widely used these days on a cruise vessels.
Okay, sir. Okay.
I got a small question that is purely non-technical. Which part of the sea you are now? You are so clear and your presentation is so clear. I want to know which part of the sea you are now.
I'm close to. I'm moving. We are sailing from Bahamas, sir. From Bahamas to Port Canaveral, which is in Florida. So we are somewhere in between, sir. Bahamas to Florida, yes, sir. That falls in the Bermuda Triangle, sir. So
it's also a request that you come on leave if you are in India. Please do visit Amet and exchange some more knowledge so that we all get benefits.
Sure. It's an honor, sir. I will definitely come, sir.
Sir, excuse me, sir. Next one student asked the
Yes,
question. Also, ask is cruise line better or gas carrier? Cruise line better or gas carrier?
It's a very typical question, madam. I think all seniors here would agree with me. Whichever ship you get, even a livestock carrier, please get into it. Don't wait for a better opportunity. Once you have your license in hand, then you can think of moving to different ships. But technically, gas tankers have more value. I think all seniors would here accept. Cruise lines have, there's a lot of fancy thing, and but you don't really get to learn much. Start off your career, look for a gas tanker if you get a chance. If at all, whatever you get it, whatever comes your way, please grab it.
Yes, sir. Sir, it won't be nice if I keep quiet any further because the time is running short.
Sir,
And the next
excuse me,
speaker is
sir.
getting ready in the platform. Now, Shanti madam, can you just give me some time, please?
Next question, one student asked, how have hydraulic system changed from hydrolocus and actuators on tankers? How have hydraulic system changed from hydrolocus and actuators on tankers?
I really don't get that hydrolocus part, Bada Saabs. Anybody, if you can enlighten me on that. Hydrolocus, really, I don't really get that, madam.
Okay, sir. Next question, sir.
No, actually, I served in a vessel where we can operate the tanker walls by the actuators. There were modules fitted. So those modules, we can operate them. So from CCR, you can operate everything. I served in that vessel, and it has got 4 or 5 stations are there. One in the
power packs.
Like
power
that.
packs, yes.
Of course, entire system is hydraulic only, but the actuators are all by demand. The electric, sir. Hydraulic, but supply are now from the electric.
Okay. It is part of SOLA's requirement also, sir, for a ship like cruise ships, that the valves like sea chest valves, overboard valves has to be controlled from an open deck. So all these valves are operated hydraulically. We have power packs in different zones.
Exactly.
And the hydraulic pressure goes to turn the valve.
That is what he means by locus, hydrolocus and then actuators.
Excuse me, sir. Another student
That's
asked
right,
a
sir.
question.
Yeah, okay. Thank you for that, sir. Okay. Yes, madam.
Would you like to know more about autonomous ships? How to learn?
Okay. Autonomous ships, at this point of time, autonomous ships are still being discussed, and it is not a reality yet. Autonomous ship, yes, it is interesting to learn, but it has not come into reality, which, even in our meeting recently, our owner asked, why don't we have autonomous ship? It is simple for the owners to ask because they want to reduce the cost of operation. But autonomous ships, madam, what we understand is it's still not into a reality. But as I said, autonomous is something that is controlled from the shore. You cannot completely remove human at all. There has to be some human. So you are going to reduce the manpower. So the communication system has to be made stronger, and then autonomous ships are very easy to achieve.
Okay.
Yes.
DPO. My note is, what about the electrical propulsion future? There will be a electrical propulsion in all fleets and all vessels, or else?
Yes, electrical propulsion is definitely going to be the future, sir. It is not going to be any more mechanical propulsion. Right now in Papenburg, where our 3 ships are being built, there are about 13 ships built, sir. Not even one ship has got a physical propulsion. And also, we did a dry dock in Brest shipyard in France. So we went the building yards where all the cargo ships. No more, sir. It's all going to be LNG powered. It is all going to be electric propulsion. The mechanical propulsion is slowly going off, sir. Electrical propulsion. Yes, sir. Go ahead, sir.
So, small question to you. In this part past reasons, right? We are just coming across with large of developments in the field of marine, right? So if at all, if all the ships are automated completely, does it have an impact over the career of the mariners?
Definitely, sir. Definitely, that is the topic. Even you can Google these days. Yes, that is going to reduce, sir. But then the need for human effort has never reduced, sir. If this way is closed, there will be different ways, sir. If we cannot operate the ship from ship, then we'll be operating it from home, sir. So definitely there will be a need for maritime people. That's what is my opinion, sir.
So will it be completely 100% efficient when people are working from the ship and from working from home? Will it be completely?
I would think so, sir. I would think so because human errors is the cause for everything. But then you can't completely remove human. Like I said, you remove them from here and put them there. So by replacing human effort into by machines, definitely improves efficiency. But that cannot be the ultimatum, sir. So human effort is definitely required, sir.
Okay, fine.
My 2 cents, sir. My opinion. Thank you. Thank you.
Sir,
But
excuse me, sir.
with this
Another.
communication system, now now this office is able to keep a track on the ship at every second. I mean, every moment, and even on the fuel consumption, ROBs, and in fact, the weather in your. So, as a chief engineer, they are even able to dictate to you. Okay, you go at this speed, reduce speed, everything they are able to do from ashore. Let's
Definitely,
say,
sir. Definitely.
yeah.
Definitely, sir. I was a chief for the. Yeah. Go ahead, sir. Complete your question.
Yeah. So, how do you take this? I mean, for people, I mean, I said in 90s, so where we had a lot of, let us say, freedom. I don't know whether it is the right term to use. When we can do things on our own, we can take our own decisions and all that. But now the office is just sitting on your head. I mean, earlier it was whatever we were reporting to the office, and now it is the other way around. They are telling you increase speed, decrease speed, do this, do that. Is that autonomy gone on board ship? Is that gone? How do you take it, Padasab?
It is gone, sir. It is gone. When I was a chief engineer 2 years ago, and I was thinking, like, I used to give them some, I used to tell them, why are you, breathing on my neck? I used to get angry on the super. Right now, I'm sitting as a super, and this is what the chief engineers here tell me. But you're right, sir. This is something, this is a negative side of that. Sometimes they overwhelmingly, they come to you, as a judge on the scene, you know better, you decide better. But as a owner, they always have a different vision. No, they call you and tell you, why are you running three engines? Just stop to one generator. You can still run. Sitting here, I know what is my jacket temperature, or I know what is the practical condition, right? But still, they would call me and tell me, stop one generator. That doesn't sound comfortable, but yes, sir, that happens a lot. And there is a lot of visibility, sir. You do a mistake, there is no margin of error, sir. They definitely know it.
Yeah, lot of visibility, yes.
Definitely, sir.
Okay.
Definitely, sir.
Sir, Shanti madam, can I go ahead, please?
Yes, sir. 1 second, sir.
Thank you, sir. Thank you for your
Thank you.
invaluable insights to our cadres and participants. We strongly believe that your speech would have ignited our participants' minds in safety and efficiency, leveraging new technologies and digitalization in shipping. Thank you so much, sir.
Sir,
Thank you, madam. Thank you all. Yes.
Yes.
Sir,
Sir, from
one
as a
student
principal side, I would like to thank you very much, sir. And of course, the audience, of course, the cadets would have really, understood whatever you said. And of course, there was a lot of questions, interactions. It is all a healthy atmosphere, I should say, doubt clearing atmospheres, I should say. Sir, above all, the pain that you have, I should not use that word called pain. Mariners, we are showing the level best of timekeeping, as well as wherever we are, in whichever situation it is. So midnight, 12 o'clock, when you say, here we relax, but there on board a ship, we are committed to our commitments. So as as a principal of a very big esteemed university, I thank you with full hearted, and we will look forward for your further interactions in the next coming, meetings too, sir. Thank you very much, sir. Thank you.
Yep. Thank you, sir. It's an honor to meet you all. Thank you so much for this opportunity. Thank you.
Thank you,
Thank you.
Thanks.
Thank
Bye.
you, sir.
Thank you.
Now it's time to move to our second chief guest. So let me confirm whether our second chief guest is available here or not.
Thank you, madam.
Yes, sir. Next guest joined, sir. No problem, sir.
Okay.
Jayral, okay, sir. Okay,
Just
ma'am.
unmute.
Okay, sir. Okay, sir. I have immense pleasure to introduce the chief guest, Dr. R. Vijayarajeshwaran. Dr. R. Vijayarajeshwaran, MD of VI Microsystem Private Limited. Previously, he worked for Central Electronics Research Institute, CSIR, Government of India, Madras as a scientist with wide knowledge and exposure with FFT analyzer, DSP microprocessor based system and instrumentation. He also worked with Pragati Computers Pondicherry as a manager in the fields of R&D, production, marketing, and administration. He promoted the company VI Microsystem Private Limited Chennai in the year 1986. The company is manufacturing trainers to cater 30 laboratories like microprocessors, etc. Also, he developed turnkey projects for defense labs. He has published many articles in international journals and is a co-author
Sir,
of
now
book A
joins,
Practical
now
Approach to
little bit
DSP.
reduced.
He is
Two
the
or
chairman
three,
of
sir.
IMC of Government of ITI. Now, I call upon
Solun,
Dr. R. Vijayarajeshwaran, MD of VI Microsystem,
Okay, sir.
to take over the center stage to carry out this session.
Before that, I would
Okay,
like to say a few words, sir. Thank you very much for being in this panel, sir. Just now we heard the first speaker talking a lot about the electronics engines and the electrical propulsion systems which are coming up, which is going to involve a lot of microprocessors and so on. Sir, in our marine university, Amet
Yes, sir.
University, here I always respect my
Yes,
Triple
yes,
Dean
sir.
madam, Dr. Sasilata madam, who takes
Join
great
sir,
initiative,
now you
who has
come to
also
Google,
taken
sir.
great initiative in this program.
I allow
And
you. I will.
I always keep discussing with madam and telling madam that we are mariners, we are very weak in electrical and electronics. Kindly please help us. The earlier speaker too did mention that we are unable to read a electronic circuit, and he has conveyed that to learn more on how to read the electronic circuit. So not only just reading the electronic circuit, sir, to go deeper into it, I hope we look upon you, we welcome you as a whole of Amet University, from Chancellor's point of view, Vice Chancellor, Register, and Dean Academics to be here. We welcome you, sir, and the stage is yours, sir. Thank you, sir.
Sir, his mic is not muted. Muted, sir.
Thank you for this opportunity, and I think I especially thank Professor Santi madam, and you all giving a very good opportunity to us. And this IoT is multidiscipline. It is not belongs to mechanical or electrical or electronics. It's everything is combined together. For example, if you see the ship is been designed using a software called CAD software called NX, that is from Siemens. They added now MCD, there is mechatronics concept design. So they are coupling with the mechanical, with the PLC, and so many simulation sensor, everything together. So that way it's become much easier. So everywhere now it's a simple CAD-CAM design has become a more complex design of electronics, sensors, and controllers, everything. So it has become interdisciplinary now. So this today my talk. It's going to be a little more on electronics, but I think it will be interesting for all of you. And so I'll share my PPT now. I think you have to give me permission to share my PPT, madam. Hello.
Yes, sir.
Hello.
Yes, sir. You share.
Thank you, madam.
Yes, sir. You present.
But it's not there, it's not coming. No. It is
Yes,
this one.
sir. Now, okay, sir. Please share, sir.
You are not allowed to share your screen. That is what's coming.
Share their screen. When turned up, only host can share their screen.
Yeah, the host, I mean, our organization is the host. Can you just look into it, madam?
Yeah, you have to allow me. You have to give me permission to present.
Madam, you have to become co-host or something like that. That's what we are doing.
No, you have to transfer me. Yeah.
Madam Shanti, madam.
Okay. Now it's okay. This is okay. In the
Okay, sir.
screen.
Yes, sir. Now it's presenting, sir.
So you are getting my screen now?
Yes, sir. We are getting your screen, sir.
So I'm going to talk about, first of all, let me thank all of you to give me this great chance to talk to multidisciplinary people now. I think the Marines, who has to have a lot of experience in electrical, electronics, mechanical. I think more than that is a C. A lot of, I think, very interesting field. And to talk to them, I'm very happy about the IoT. So IoT goes everywhere. The Marine, I was working now recently. Fortunately, I'm working with digital image correlation people, a product from Swiss. They use a camera, they use a drone to take all the photographs around the ship. It'll tell you what is the deformation, what is the strain and deformation has happened into that. So maybe when the ship is inducted into the sea, they'll take a complete imaging, and periodically every 3 months they'll keep on taking images. So it'll tell you what is the health of the ship. So this could be applied to anything, inside and outside, and in the ship. Everything is going to be monotonous once you have put it in the operation. So the generator or the most of the rotating machines, all the pumps, everything going to work continuously or periodically. So monitoring that by manually and it is not very advisable. It is that is what this is, and it is very tedious also. If it is a fatigue, then there'll be accidents. There'll be a lot of issues. So this problem can be avoided, or this problem can be solved by using IoT. So continuously put sensors everywhere, like vibration sensors in the pumps and generators. So you'll continuously monitor the vibration. And nowadays you have a front end and the end itself. You have a computing power. Previously, about 3 years back, we don't have much power into the end user. All the data should come to the cloud or the remote server. Then the server will take a decision and they all will do all the analysis. Now we have much more technology advancement in the embedded controllers, which I'll also talk in this my speech. Where at the end, it means in the front end, and where the sensor is available, you can do a lot of computing. Including neural processing. Everything can be done. Artificial intelligence can be implemented. Then the vibration can be continuously monitored. With the artificial intelligence, you can detect the problems in advance. We call it the predictive maintenance or predictive analysis. So this could solve a lot of our problems. So the machine is going to fail after 2 days, which you can be known with about before 2 days itself. Then you can do a lot of preventive maintenance. The whole data is going to be in the cloud for years together. Then you're going to store, it's going to be analyzed. You can predict the health of the marine products like ships and everything. So even the sea, weather, all this can be completely predicted. Now, with the recent weather prediction, a lot of accuracy is improved. That is because of the cloud. I think because of the IoT. So a lot of data is going into the data has been taken through sensors and everything, bumped into the cloud. So where the huge data is for years together, then the prediction is very much more easier. So this is definitely a good subject. I think IoT is gone everywhere. In the marine also is gone. So I'll just go through what is the way it is needed, what is the technology, what is the fundamental structure of that, what are the commons are used in IoT. All these things I want to cover for about one and a half hours. Now the smart manufacturing, smart industry or IoT 4.0 has become popular everywhere. People are start introducing IoT industry 4.0. Without that, you cannot run a very huge mass amount of production. For example, we are now for the past 1 year we are installing in one of the industry in Madurai, industry 4. Almost we are completed that. So you get a more efficiency. You can debug, you can do a lot of things in this. Here, the IoT is going to be connected to all the equipments, your lathe, your milling machines, or any equipments. Going to be through sensor. We are going to connect, and we are going to do. It goes to the private cloud or a public cloud. So then the data is going to be completely analyzed, and it's going to be integrated with the MES. That is another software which is very useful for the implementation of IoT industry 4.0. Then the MES, it connects all the machinery, products, people, for automations, robo, everything else is going to be connected to the MES, and MES is going to do a lot of interaction with the robo and everything. So the product himself is communicate with the machines and initiate the next manufacturing steps. So that's kind of automation is coming into that. So MES became more important. MES is a manufacturing integration software. It become a real-time integration of IoT sensor in electronics and mechanical productions, and the informations and everything. So it monitors and synchronizes the execution of real-time physical process involved in transforming raw materials to finished goods. The ship, it is applicable to ship also. It is a very shipbuilding. This is what they are going to do that. And it is an advantage, a lot of advantage. Let me not go deep into that. And if you see that any manufacturing, any mechanical system, any shipping system, you'll have a conveyor belt. And the conveyor belt is going to be powered by a inverter with induction motor. So we call it as a vector control drive. So nowadays, previously this equipment will not have anything. It will not have any special features. Now it has got a more intelligent features. It's connected to the IoT. So you have an intelligent PLC built into that. It's just so I want to show that one of the commands used in IoT, or one of the commands used very regular, very intensively into the Industry 4.0 implementations. So you have a special support protocols meant for IoT. It's called Ethernet CAT, and many features have been coupled because of the powerful embedded controllers now available. Traditionally, they use it for controlling the speed control of the induction motor only they use. Now they add more features like connect to the IoT, connect to the PLC, connect to the much more information you can put into that. Now, I think they are going to add feature the drives. It is called the drives. They are going to add artificial intelligence and predictive maintenance at here will be built in. If you see, you're going to buy another 2 years down the line, in this drive will be upgraded to predictive maintenance. Plus, it is going to have a MPC algorithm also into that. That's one of the latest algorithm which is going to be incorporated into that because of the evolvement of embedded controllers available into that. And this is another product, very useful product for any moving, any rotating machines. Like in ship, you have big generators, big, pumps, everything will be available there. So to do the maintenance, or you do the predictive maintenance. So you can use this intelligent condition monitoring box. It's all rotating machine condition monitoring system. It has got a direct connectivity with a built-in connectivity. It's a Israel product, narrowband IoT connectivity. You can directly talk. You can go to the satellite directly. So we can do a lot of. You can predict when the machine is going to fail. So that's the advantage of that. And the semiconductor industry now, if you see, if you are a regular reader of a newspaper, there's a lot of shortage of semiconductor. The ICs, embedded controllers, everything, especially in the automobile. So I think if you book now a car, it may be delayed by another 3 months or 4 months because of the semiconductor shortage. That is because the IoT is exploding. So for IoT, they are putting a lot of products into the market. So there is one of the companies, a Nordic, is a fabless company. That means they don't have a fab, but they give it outside. They design a lot of chips. This is one of the chips, NRF 5340 SoC. You see the features in both. It's got a dual core processor. If you see the computer, you'll have 4-core, 6-core, all keep on increasing. The latest i3 is a 4-core engine. Like that, it's got a dual core with the built-in Bluetooth, with we call it a system on chip, and low energy Bluetooth mesh networking, NFC, thread, SIP. All these are needed to implement the IoT wireless technology. It has got a Cortex M33, that is one of the latest processor with so much features. So this is flooding. I mean, this is all flooding into the market. So next is another IoT IC, which has also got a lot of features into that. And this exhaustive set of sensors. We have a temperature, humidity, air quality. We are just presently, I'm working with a team of intelligent, very innovative people to find out corona. So we are monitoring temperature, humidity, many parameters using a embedded controller, and we found we are able to detect the adulteration of milk. So we got, I think, there is a pattern also on that. So now we are trying to detect corona by taking samples and everything, trying to find some other. This is one of the embedded IoT. Then we are trying to connect it to the IoT also. So if you are successful, it will be within few seconds or within 1 minute, you will get a corona test will be over, and it will be connected to the IoT immediately. So you'll know the figures automatically. So this is the advantage of the IoT. So this exhaustive sensors added to that, so can be used in multiple applications. Predictive maintenance of ships, marine, all the marine products, logistics, asset tracking. So in the sense asset tracking, this will have built-in of matters, accelerometer, everything. You are sending asset like you are sending a corona medicine, the vaccine. This should not fall. You should have some particular temperature in traveling. So if you in the packet, if you put this model into that, it'll keep tracking. It'll go to all the data needed for that, like vibration, falling down, temperature, humidity, everything will be locked onto the IoT. You can keep track. The supplier and the customer can keep tracking what is there. So it's called asset tracking. So it's getting more and more popular. People are mad and working on the models for that. In fact, we are also working on a big model meant for fisheries, sending fishery materials to this one. Smart agriculture, another big field with the drone and everything. So automation is going to happening there. And wearables, medicals, everything is become a very big one. You may wonder why I'm talking about on the 6 subjects. So when I joined as a scientist in CSA, my first project is a condition monitoring system. You know, that is a FFT analyzer. So I did it in 78. That time there's no processors. Like now you have an embedded processor, everything. That time I have a bit slice processor. Using that, I built my own computer or my own embedded controller. I made a FFT analyzer. So which is a competition. We want to indigenize one of the technology from the PNK. They are the dominant. So that is the one we have done that. Then I used to work on our embedded system every day. Then I moved into that condition monitoring system, one of the components right now for the IoT. Next, I moved to a computer company called Prakriti Computers, where I design and fabricated computers or design basically. Starting Unix. My last project was a Unix. So now that has become a Unix-based machine, 32-bit machine. Now that has become another component of that. So sensors and everything. So with that background, so then after I think we started this company in 1986. We did a lot of work, a lot of innovative work on wireless technology. Around 12 years back, I made a wireless sensor networking. That time it's called wireless sensor networking using Zigbee. So that is a big, that I think few people done a PhD in our this one. So now that has been called as an IoT now. So a lot of this one. So with this background, even still we are working on many products now on IoT and everything. So that I'm giving this lecture. And if you see this marine, there are a lot of scope. If we see this one, you'll get a lot of sensors. You can either in the ship or you want to monitor the complete sea belt. You can put many sensors. You can take all the sensor sensor output. You can send it to the cloud and keep it for your picture analysis. And this is the way they implement this. So you put a lot of sensors, everything. Whether Zigbee, Wi-Fi, LoRaWAN. Now the LoRaWAN, Zigbee is meant for short distance. It has got its own advantages, mesh networking, everything. You have a number of sensors more. You can use that. LoRaWAN has got a long range, 22 kilometers, and very low rate. So that can be used. So many technologies improving now. The narrowband IoT. So that you're going to use GSM or the 5G. They can use. Once 5G is come, it's everything or through satellite. If it is in this mid-sea, it's going to be in the satellite. And the data is going to be stored in the, or it's going to be processed and stored in the remote server. We call it as a cloud server, and the result can be sent to your cell phone, smartphone, or your laptop and everything. So this is one of the implementation. Strain and information deformation analysis, one of the big things. DAC, we call it as the DAC. So you have a ship. So over the years, whether it's going to be a problem or something, you can send a drone. These are the information you can take. This is one of the because I've taken from the software. So the drone, you can fix the camera to one or two cameras. You can send it through this ship. Around the ship, you can fly, take all the information. Then it can give you strain and information and deformation analysis of the ship. So if any problem is there over years, you can inform, so they can repair it in time. So when it will become, I think tomorrow it will become a compulsory to do that, so that ships can be in healthy conditions. So this is one of the big application for marine. So IoT applications, and this is the software for that. It's, I think, Swiss software which you are talking about that. So you calculate the 3D position of the surveyed points based on the photogrammetry. It will give you many more information on that. So that's right. And some of the results, it's like a fingerprints. You take the surface photographs using the DAC. That is you can get a lot of information from that, and that are some of the information is displayed here. I will not go deep into that. It is all possible now. So you can use the IoT applications. Marine applications can be huge and can be so much advantage for them for the marine field. But recently, we see there was a article on Hindu or on some newspaper. LoRaWAN based water meters, smart meters, have been installed in 10,500 buildings in Chennai. So it's going to be more. I think if you put a water meter, a smart water meter with the LoRaWAN with a solenoid wire fixed into that, you can completely, this water distribution can be completely monitored. If they're not paying, they'll cut off. I think the first stage they is going to install in all the industries and commercial buildings. After that, they'll come to this. I think Delhi, everywhere they're installing throughout the world. It has already been done, so it is easy to smart meters in the house. It is now people has to come and take the readings. I think tomorrow, once all the smart meters install, automatically will know, and they'll cut off also. It will not paid in time. So all the advantages there. It has got a more advantage. All the data is going to be in the cloud throughout the country. All the meters, consumption meters of electric meters are into the cloud. And then the government of India or the central body who is responsible for energy generation can monitor and can completely take the proper decisions. That's all going on. That is another advantage of the IoT-based smart meters. And the Geo is in a big way of talking to IoT. They're aiming for 20,000 crores to talk to a lot of OEMs and everything. So they're going to tie up with a lot of OEMs based on a narrowband IoT. It is not right now, it's available. That is why they're delaying it. Otherwise, it will come. Your house, everything will be monitored. You can take the service of Geo IoT. So there's going to be 1 billion devices going to be connected. So 20,000 crores revenue. So that will be definitely applicable to marine also. It will be meant for smart city, major hospital, smart meter, smart bulb switches everywhere. So they think, and Airtel also going to is coming out with the same thing. So your house, all the house, and in future is going to be connected through Geo or something for implementation of IoT. And IoT has got a lot of challenge, even though it looks like a simple. You put a sensor, put an embedded controller, and put on wireless technology like Wi-Fi or Zigbee, then transmit to a remote server. So it looks like simple, but it is very complex. It is different in terms of availability, security, networking. So many things are there. So it just become complex. I think Cisco made a survey on industries. So in a lot of industry, 60% of industries failed, and 70% people are not able to understand. So it is a little hard, this one. And even though I'm working on this field for long years, but looks like simple, but when you implement, we have a lot of issues, and it's coming. And every day there's a new device has been implemented for IoT. This is a watch which will give you everything when you wear watches in the hand. It'll give you body temperature, heart monitoring, oxygen level, everything. Now it's in Corona period, everything is going to be monitored and put it in the cloud. Today when you're sick, you go to the hospital, they take blood sample, CT, and all the equipments. They'll use X-ray and everything. Then they'll analyze. They'll give you, the doctors will analysis and give you, this is what your disease. Tomorrow, all our activities through this smartphone, everywhere, it's going to be going to the computer. So it will predict when we are going to have a critical disease, or when you want to have a problem. Like now, drivers are some drivers are driving, they have a heart attack, then they made an accident or they saved by dying. He will die. So this can be completely not be there tomorrow. And tomorrow, I think all our cars going to be electrical car with driverless, because everything is going to be in the cloud. Because once 5G comes, everything is going to be, so all the sensors, everything is going to be controlled. So tomorrow, this people like Siemens, people like GE, they are the big makers of these hospital equipments. They'll not be there because of the IoT. That is a prediction they are doing it. So it's a big thing. So we all should know. So this is measure the body temperature, real-time heart rate monitoring, check blood pressure, and I think Tata is introducing a trialathon. So it will give you, when you're walking, it will give you a lot of information for you. It is going to give you a lot of other. So all our activity is going to be in the cloud. So when you walk for 1 hour, I think the old people after 40, they go for jogging, walking, everything. When you go for, this is in the swimming also, you can use all the information. It will go to that. So depends on the heart rate, everything. They'll predict when you're going to have a disease. So Apple Watch is going to monitor the blood oxygen, and this is for this for our body, and for machines, condition monitoring through IoT-based condition monitoring system for any rotating machines. And now with the artificial intelligence at the edge, so you have a lot of microprocessor. This is a Carcass Frame 4 based microprocessor or embedded controller from unlocked device with their sensors. The Israel company built an intelligent condition monitoring system, which I built around 20 years back. So they built it with the simple. They have a lot of tools now, embedded controllers, so they're very easy to do that. So this equipment, we call it the Echo Marks. It has been approved by Siemens also. So Siemens also approved this. So the Echo Marks features, they have 5 high quality sensors like vibrations, magnetic field, temperature, sound. Using sound also you can detect, you can predict. Your fan is in the house, the fan is not working or not properly working, it will give a different sound. So using the sound also, there are a lot of research is going on using sound how to predict your machine's health and the current. So these are the 5 parameters they put. They have artificial intelligence and machine learning also into that, into the edge. It's not doing it in the cloud computing. It is doing it in the edges. And now there are a lot of beautiful processors that come, which I'll discuss for 1 or 2, but there's so many things are coming in. So jets and so many things are available. So this information relayed directly to the cloud. There could be all the raw data can be sent, all the detector, what is the result, end result also can be sent to the cloud, so that the memory will not take much. And it can predict and prevent performance issues. That is that is what needed for any rotating machines. And it can be installed within 5 minutes, that's all they're telling. So I think you'll have a lot of in marine, in the ship especially, you'll have a lot of rotating machines, lot of rotating. So you fix everywhere. This one is not very expensive, around $500. You fix everywhere, put it into the cloud. It not only tell you the sailors that this your particular machine is going to fail, or some problem is that this is all happened because of this particular machine is characteristics like that. So or the labor is not, or the manpower who was attending this is attending a mistake. All this can be corrected. So in other places, like if you are milk on the Avin milk, they are making they use hundreds of pumps and everything. In some places they produce the milk and they packet it and send it to Madurai. So there they found some problem with one particular batch, and if they refer to the Avin, they are able to tell you why this problem happened because of the particular machine or particular time. Everything is in the cloud. Your time, because you are in the IoT, time stamping also will be there always. So particular time, particular period, a particular batch, and this has happened because of this mistake. Then that could be avoided next time. So that's a big advantage of this IoT. IoT based PLDC motor. Now I think you'll see the advertisements, 2,700 rupees or 2,500 rupees. You have a IoT based PLDC based motor. Now traditionally you have induction motor. And PLDC motor is much more advanced, more reliable, more faster, more. I also did my research on the PLDC motors, and this is it's going everywhere. The PLDC motors. We expect SR motors will come up in every big way, but that is really a second step. But PLDC motor in your two-wheeler, in three-wheeler, in your four-wheeler, everywhere the PLDC motor is coming into the picture because it's a more advantage than induction motors, and that is because now they have added IoT also into that. So that becomes much more. Your house is going to be IoT enabled tomorrow. It is there now, but everything is going to be common tomorrow. I think that has got a lot of advantages. IoT based trip education for agriculture is one of the boom. It can be standardized, can be do that. So remotely you can control because a lot of issues with the irrigation so there because of watering, manpower, so many issues. So automation using IoT is going to be the great advantages. Now it's happening. And the IoT, we are talking about so many advantages. Whether it's scalable. Yeah, it's scalable. Every year they are putting more sensors connected to the IoT. So they expect 50 billion in 2020, or it is already over. So it must be increasing from 50 to 100 billion devices going to be connected. In the house, we are not connected. So if we all put together, I think another 5 years, that's going to be 100 billion devices. So you need engineers to maintain, you do a lot of design, a lot of data analytic people. Now the most highly paid is the data. All the data is coming into the cloud computer. What do you do with that? So you need a data analytic people. So a lot of courses now ASD is putting the data analytics, data science. Now, so they're removing instrumentation, electrical, and they're putting this. I don't know what will happen tomorrow. So there'll not be any electrical engineers. So the electrical engineers, what do you do? Instrumentation they are removing because of these problems. So they are putting a lot of IoT sensors connected. So more than 50, 100 billion. This one they're going to be there. And demand for IoT is also increasing. Every day is increasing. So as I told you, I'm working on another project of IoT enabled, which will measure, which will monitor acceleration, magnetic, and Bluetooth, everything. We'll fix it in all the containers of assets tracking. So once there, I think it's going to be billions. So that is also happening now. Then data generator, country-wise, because of the IoT, everything. So in US about 32%, in Europe about 19%, in China it's about 13%, but India is very, very low. We are not started using that. So I think so there's a lot of opportunity for each of us to work on that. So like L&D recently has got a contract for 5 million smart meters to be connected to the cloud. So that's when the work involved meter installation, data storage on the cloud. So preparing dashboards, data analytics. So first it's happening in UP because I think everywhere they're going to put. I think every house will have smart meters. I think tomorrow, even now it's the space needed for 1 kilowatt power generation using using solar is very, very small. So with 3 solar panel, you can have about 1 kilowatt. So the price also coming down on solar panel, and the inverter also coming down. So mass productions, new technologies, new this one. So it's going to be very cheap. So every house is going to have a solar power generation. So the smart meters both way. When solar is generating, it will not take any power from the grid. When it's not generating, it will take the power. So it will work both way. So that way it's the smart meters going to be a compulsory in all the houses, because every house is going to produce electricity also through solar or wind. Application of this IoT is enormous everywhere: transportation, healthcare, smart environment, and personal and social domain. Everywhere it's going to be there. In healthcare, it's going to be a little more complex, but they're going to have, they're already coming into that. And transportation, already they are using it. Cheap everything, smart home. I think the costly houses, everywhere they are putting in whatever possible. I think everywhere it is in an entry level house also. It's going to be there tomorrow. And smart industry, that is another big application of IoT. Smart city. Smart city, you already would have seen one of the advantages of implementation through RFID toll collections. It is completely automated now. I think they are picking advertising now. More than 100 cars are there. It takes time. It is only free. So that means they are going to lose their revenue. So they are going to work very. So it is completely networked through bank. Everything is automatically. It is RFID tag. It is fixed on that. The IoT sensor is another sensor. It is come to the cloud or go to the server. If you have money, it will open the gate. Otherwise, it will not open. So a lot of issues now happening. They are solving that. So it's another very good application for the smart city using IoT. So it can open automatically. So now it is, once you are crossing a Sengalpet gate, it takes a lot of time. Now because of IoT, it has become very easy. Now there is no crowd at all, most of the places. Electricity metering, point of sale. So all of your operations, all of our life activities going to be in IoT. So when you purchase, that will go to the cloud. So your financial tracking, everything is going to be useful using IoT. Logistics, that is asset tracking is one of the great advantages for us. Now, previously, if you are sending a courier, a box or something, it is difficult to track. Now, you do not ask anybody. You go to the site, how to find out where your asset is, where your courier is available, in what state. Now, if you fix that IoT, this one gadget, which will give you acceleration, vibration, and everything, humidity, then you can know what is your health of your asset, whether it is a good stage or how many times it fallen down, or when by the time it reaches the one, it may be breaking down, gone. We also get lot of consignment from China and everywhere. Sometimes it is all broken. So that is because of this. So then it is not useful for the production. So we lose time. Then once again you have to send it back. All become tedious. So this health of your asset or health of your courier has to be good. So that is this all IoT is helping us. And people like Porsche, big companies are investing a lot of money onto the agriculture, smart agriculture. So put a lot of sensors. They are developing a lot of sensors in the plant. You know that if you have a plant, if you have a garden with vegetables, some plant is not green, then we know that it is a problem. So either you have to medicate it, or you have to remove that, or you have to put fertilizer, everything. So that way, all the information goes to the gateway. That is one of the components. The sensors is another component of IoT. Everywhere, in any field, you go to marine, you go to hospital, you go to transportation, asset tracking, everywhere. And the sensor is one of the component of that. So you put a lot of sensor. Maybe the sensor varies, but it depends on the application. In here, we put a lot of sensor meant for agriculture. Then it all goes to the gateway. Gateway is common for everybody. So the gateway is, I'll define the gateway in the later stage. Then it goes to the data cloud. So on the cloud, they have artificial intelligence. Then you can have services through a cell phone or a smartphone. A farmer can get all the information, decision making, everything on his cell phone day to day. You have to put fertilizer, or you have to put it can be automatic also. A lot of things can be automatic. So your yielding can completely improve. With the end, using a drone, everything. So this is going in a very big way. And IoT based machine health monitoring. So this is another Even this is applicable to marine also. So all these are applicable to. So you have a lot of missionaries in marine, in a ship and everything. So in industry, you'll have in smart industry, you'll have a lot of lathe and everything, and robots and everything. So this can be completely monitored, and IoT can help a lot of things for the managers. So one of the this one is continuously monitoring the asset integrity. Asset means your could be a lathe, could be a robot, could be anything on the working rotating machines. During this analysis, we and these people they sample around 100 milliseconds sampling rate. Number of variables is 98. So main variable is machine states, cycle time, tool number, spindle, servo data, and all speed, everything. Then tool clamping system, bar screw, and everything. So we also monitor the consumption efficiency, electrical energy, coolant, cooling water, compressed air. All these have been monitored completely. And one of the parameters in the current waveform of lathe or something we have taken. So if you see that the first waveform shows half of the time of the second waveform, that means there is a mistake. There is something going wrong. All this are taken, all the data is taken for about 3 months, analyzed. Then they found out there is a mistake on the CNC coding. So that has been rectified. That. So this is the advantage of the IoT. So there are a lot of books are going to come. IoT, maybe now there are many books on the IoT. There's one other book. And IoT is coming in the syllabus everywhere. So IoT meant for two industries, like discrete industry and process industry. Process industry continues, like power production, manufacturing of tablets, and discrete industry, car manufacturing, components manufacturing, all this. There's two industries. This industry is also now using extensively IoT. They're making a smart manufacturing or industry 4.0. They also add another technology is called digital twin. If you want to build a ship, you make a digital twin of that. They use NX. There is a CAD/CAM software, Siemens. It has got this is one of the commons for digital twin. So you design all your ships, data, everything there. Using the additional software like Comas and Simit or so many things, many softwares are provided. You can actually simulate after design how it is performance, everything can be done. So we call it as a digital twin of that. So that is also playing a major role. You can connect sensors, everything into the digital twin. What is actually happening, you can do that. You can design a ship or you can design a power plant completely in a simulated mode. So we call this a digital twin of that. So you can see that. So there are many softwares are available in 3D and everything. So plant site is one of the software for that. And you can see the sample software. This is a simulated or design in a software. So you can have a lot of sensors and sensor details, everything. You can your 3D this you can move into that. A worker can go into the, so many advantages that. And this another 3D one. All the sensor, everything can be simulated completely. What actually this is almost 100% actual what is happening. So in the plant completely can be simulated, executed before it is going for a construction. A car is there, the car design also they are doing the same way. It's the actual industry. So I want to just show you a machine we designed, we simulated in a virtual mode. So I'll just show you 5 minutes. This is another work we have done it for industrial 4.0 implementation. Before we fix any sensors, we everything simulated. This is called the belt manufacturing, the car they use it. So this machine is meant for belt curing. So they put the belt, number of belts, 20 belts. Then they interface with the PLC. They interface with the SCADA. So you have a mechanical system, you have electronics PLC, then you have a software SCADA. The SCADA software can be connected to MES or any other higher end softwares or Simit or any other software. If you see the left side, you have the SCADA software, all the simulated mode. What is happening in the industry, same thing we are doing it here. So on the right side, your machine. So on the left side, you have your simulations. So now we'll give all the parameters, we'll test it in the simulation mode itself. Like we are locked onto 2 sensors. One is the time, one is the temperature, and one is the distance. Distance we have speed and distance. So we are locked in. So there's a distance sensor, there's RPM sensor. Because otherwise it will take a lot of time. So we made it two, and we are now trying to. There's a HMA will be available in each operator's place. So this one you simulated, you are showing it here. So now we made a. Now you see that it is going down. The head is going down. That is now it is the heating mode. So it will have a lot of process, heating, cooling, moving and everything. That V belt has to be going through a lot of steps. So now it has gone to the heating mode. So you see that the left side also will have a distance sensor and RPM sensor will change once the go and stop. The whole thing we are doing it in a simulation mode. This actually, then after that, after simulated, the engineers went and fixed all the sensors, everything found okay, fine. So this is a great advantage of it. Anything you make now, even the students' project, I think most of you will be students. The student project also can be completely simulated. Then you can do that. Then the quality of your project works can be improved, or any PhD work, any ME work can be done using the simulations mode. Now see that RPM is 20, distance is 200 the sensors. The bottom one tally is there, that will go up and spray water for cooling. So that time you will see the distance sensor and RPM sensor will change. This is one of the actual process happening in the industry. Now see that this is going up and will spray. Little more we can have animations, everything we can do even spray also, which is not shown. Spraying and all we are not shown. And the tally will come down. That time you can see the distance also will change, RPM also may change. Yeah, you can see that the distance is changing. Now it has become 0. The RPM is now 20 RPM now. So like that we can do another programming, another changes. One more thing I'll do that, then I'll try to skip that. Now we are changing and the distance will be same. Yeah, and now the distance is changing. You can see that. One more test calculation happening. The RPM is now only 8. Now another cycle. So one more cycle is going on. So there's the next cycle. We have changed the distance is 300 and RPM is 8. Okay, so we can go and do that. I'll try to skip this because it will take another 5 minutes. I can see that for another setting it is acting. You can see that rotation there. In the top one you can see the road tally is rotating. Most of the simulation, 80% simulation you can do it with that. So this is we call it as a VRC machine in the simulation mode, the digital simulation mode. This is also part of IoT. So all the sensors will be connected. You can test everything, and then you can go for the next one. And you have a T-shirt, IoT-based T-shirts or shirts. Arrow launches shared with a lot of electronics inside. So you can give you LinkedIn. Now in the Corona period, you cannot handshake. So if you're going to meet somebody, you need the what is his profile. So LinkedIn profile, Facebook profile, visiting card, everything can be transmitted. You can see it in your cell phone immediately. So Rolf Fodor, it has got much more information. So it can give you heart rate and calories band. So the calories, how much you're walking, everything. So you're walking daily, how much, so calories, how much. But it will go to the cloud. So this week you have done so much calories band, so much food you have taken. Your heart rate is fluctuating like that. All these informations tomorrow it will be there in the cloud and it will predict what is going to be your performance tomorrow. Your iPhone is getting every day more smarter. All your smartphones, they're going to put hundreds of sensors into that and take all your informations and put it in the cloud. I would travel back. That is, if you are an international traveler, this is a great boom for us because when you take luggages, go to the counter, they'll say you have a over luggage, so I will not take you. Otherwise, you pay around thousands of rupees. So if you have already a digital scale in that, we'll know that we have over luggage, so we'll remove that luggage and put it somewhere and everything. So location tracker, battery charger, you got a battery charger also, the remote locking. The locking is another big issue. All this become IoT enabled now. It is available now. I think 40,000, 50,000 Samsonite it is there. And smart vending machines. Now you have the vending machines become going to be common. In the US and all, I have seen about 10 to 20 years back, vending machine. Everything is available in vending machine. You cannot take it from a shop. So we are also, I think we are seeing now from a small grocery shop, it has gone to now the big mall. You can buy big basket. All these are now it has gone to mall. So we don't buy from a small market, small vendor shops. You go to the people are agitating. I think slowly you'll move into the Walmart and everything. You will buy everything from there because it'll be cheaper, quality, everything they'll maintain. So many advantages with that. So it'll be moving. So that's what happened in the US and other industries, other countries. So it's also going to happen in India. So once you have automations, a lot of vending machines, everything, then you have to maintain the hardware and you have to know what sort of a customer is coming. All these are will be advantage to do in the cloud. So this is a Microsoft Azure. Microsoft Azure is one of the cloud software provider. So this machine is the hardware is locked onto that. So all the information will go there. So we can decide so many things. One is smart stocking control. So if there'll be cameras definitely. Now the cameras are detect what the age that customers are coming. So it depends on that. You can stock also. The youths are coming, then they'll take more chocolate. So you can put more chocolate into that. Or drinks, maybe Coke, they'll be taking more. Maybe old people, they'll take less Coke. All these things can be completely monitored. So the hardware also you can maintain from there. Every time you send, there will be hundreds of thousands of vending machines will be there. You cannot send you cannot have a hardware engineers. So that has to be maintained automatically or sure some other way of doing that. Now every machine, big machines coming from US or everywhere, they have IoT enabled. So everything is maintained through remotely. So smart target targeting, smart interaction, all these are advantage of that. Then in a petrol bank, so you have IoT, the owner can monitor from remotely. So theft, everything can be completely reduced. The service also could be much better now. So you are now in the house, lot of penetration of your IoT. Your fridge has got IoT enabled. So there are a lot of advantages. Your fridge is going to be a fridge, ACs, everything is going to be this one. In the if you see the fridge, you have a number of eggs. You have a sensor to detect that connected to a shop where they supply you the egg. So it automatically inform them the egg is reduced. Maybe 2 eggs is there. Then they'll come or they'll send a boy with the eggs who can be loaded into that very easily. So you can have an automatically now. So since we are all become professional doing a lot of other work, we don't have time to maintain all this. This could be saving our time. Even that time you can put it on something else. So your AC is going to be a IoT enabled. All these are now come as the advertisement. You can see the advertisement IoT enabled everything because the latest technology they put into that. And your maintenance of pressure compressors. That's one of the big things for the industries. They have a 5,000 PSA everything. Now I have put here the left side there is a compressor. Right hand side I have put on Siemens IoT gateway. So directly coupled. So it will take all the information like vibration, temperature. Everything will take and put it to the cloud and predict when to send the service engineers or what is the service contract can be maintained. That power generator. Power generators also in the big apartments they have a 250 or 1 megawatt. In data centers they have a power generators of 1 megawatt and everything. So all this can be maintained. It's all very difficult. If you collapse your whole service will be collapsed. Your email, everything will be collapsed. So all this, this IoT helps a lot in that. And then said automation in colleges and everything can be very much useful in that. So this is the one way of implementing that in IoT. In all the trains in the compartment, we did a work for one of the master ME project. So we try to monitor complete one compartments, all the parameters, and through a gateway we sent it to the cloud, then did a lot of inference, conclusion on that. And we also done a lot of automation through IoT in colleges. This is one of the colleges where we did RO plant automation completely using this IoT. 2020 is one of the gateway of Siemens. We put a lot of sensors, everything become automated now completely. We use a SCADA PLC 1500, everything we use. And this is the implementation of ROT. I'll not go deep into that. I'll just this is a 2020. It's got a lot of advantages of Siemens. I'll tell you later. Then the plant automation. This is a complete integration of that. Then the campus plant watering also we did it. Then this is a control system we implemented. Then we also did this is a vegetable cordon through IoT. So this saves a lot of time. No, if you want to watering manually, it will take about half an hour. With IoT, with automations, you can do it within 2 minutes. Then we got a lot of other issues which has to be resolved. So there's a very simple controller can be used. Arduino can be used, or Raspberry can be used, or some other sensor can be used. This is going to be big. This they are using in all the remote, in villages. They started using these automations. People told me, the solenoid was used in agriculture. When I asked for 2-3 numbers, they laughed at me because they buy in thousands in India. So that means a lot of automations using IoT is going on because they are very seriously doing that. So considering this, IoT is the big things. So Government of India introduced 3 courses. One is an agriculture, IoT technician, smart agriculture, and IoT technician, smart city, IoT technician. But this is a 2 years course, smart healthcare. ASD also given you a lot of courses, BE, data center, BU, IoT. They also start introducing IoT courses. A lot of books, a lot of things are there. So this could be, defined Internet of Things for short. Extending the power of Internet beyond computers and smartphones. So usually we have computer, we have Internet, we have this. But to the other things like process, environments, things, everything is going to be connected. So it will have the ability to transfer data over a network without human to human or human to computer interaction. It will go automatically. So a lot of things are going to happen. A lot of things already happening. It's going to be a lot of because of the lot of developments happening in the technology. And what is this IoT architecture? So this will be one of the core of that. This is what. So you have a sensors. It's one of the component. The sensors are connected to the microcontroller. So microcontroller usually will have RF, one of the RF, Zigbee or a Bluetooth or a LoRaWAN. Then that is connected to a cloud through gateway. Then with the security, a lot of security is one of the big components. And connectivity is one of the big components in the cloud computing. These are the components of that. And if you see the implementations, you have microcontrollers with the digital signal processing, ADC, everything. Through that, you connect your sensors and actuators, and that goes to through gateway. Usually, you use a gateway because of or you can directly also send it to. You have protocols like MQTT, everything. You can directly send it to the IoT cloud also. And this is the technologies, the device-wise. If you are electronics engineer, you'll be more interested in the device hardware and everything. The mechanical will not be much interested in that. You need only block. So I don't think you should be worried about more on that. People are mechanical everything. You should not worry about that this much because this can be used as a block. Like computer science people, computer science students, they're using a computer. They use a software. They'll be more familiar with the C, Python, everything. But what is inside the hardware, nobody knows. Either the i3, i5, or a Xeon processor, nobody knows. But it is not needed or I do not know. But nobody knows. But they are using as a block. The same thing, the IoT gadget also IoT blocks, IoT microcontroller based boards will be used as a block. So for other people. For electronics people, electronics and electrical people will know the inside. Will be also interested in the inside. So this is the inside of that microcontroller. So many microcontrollers are coming in based on M3, M4, M33. So then FPGA. So many things are flooding the market. It's very interesting to see that also. As far as I am concerned, people like me. So we are more thrilled on that. People with respect to the data science people, data analytics, they'll not be interested in that. They'll be using as a block. So okay, I'm getting the sensor input, and that's coming into my me, that's enough. So inside, I don't know what is happening. So there's a multidisciplinary people of the specific interest of individual people. So this is one of the IoT sensor, temperature sensor using Zigbee. We designed, this has been designed for training the students. Now you can put the protocol, everything you can change. You see that we have a 1, 2, 3 boards. The top board is the RF board with the microcontroller. The bottom board is with the battery, the termination board. Through that you can connect a temperature sensor. You can connect any sensor. There will be about 6 sensors can be connected. And the students of the training can understand what is going on there. Then after the later they can build their own gadgets. This is meant for a training purpose. This is based on a controller called CC2538. It's from Texas Instruments. It's one of the famous company for making controllers, ICs and everything. Based on a Cortex M3. This is very old, 10 to 12 years, still active with RF transceiver. That is called Zigbee. So this is will be the structure of the front end. This one, there could be instead of that LoRaWAN will be there, instead of that Bluetooth will be there. So basically this structure will be the same. And how this all connected. So this is a block diagram of how these are connected. You have the center of the place, you call it the semantic IoT 2040. That is a gateway. This is an embedded controller. This is nothing but an embedded controller. They are ruggedized. So this will work 24/7 into 360 without any fan. It will be like that. So this one, you can connect anything. Your Modbus, Wi-Fi, all this will be connected to that. So that will go to the cloud. In a smart industry, this barely will be connected to your DCS. You know, in any industry, all the machineries will be controlled by a PLC or a DCS. So it will be connected to the DCS through Profinet. So there another interface, industrial interface. Usually, traditionally they use a 4 to 20 milliamperes. Now they use a digital because the IoT. They converted the Ethernet into a real-time protocol. This is called the Profinet, EtherCAT. So many, about 8 to 10 protocols have evolved, all 100 Mbps. So this is connected. This is connected through a DCS for that. So this is a typical architecture of IoT implementation. Anywhere you are in a marine, you are in a house, or anywhere, it's going to be like maybe there will be variants. That's all. In a chip, in a customer, in a mass production, this will be SKUs in everything 1 or 2. That's all. The structure will be same. And if you see that this is another structure. You see the centralized place is the gateway. To that LoRaWAN based cluster of sensors are connected, and Zigbee based sensors are connected. RFID based clusters are connected, and Wi-Fi based are connected, and Bluetooth are also connected. All these are connected to that. So this is one of the architecture of that. And basically what you are doing is a digitization in IoT or Industry 4.0. Everywhere this is a digitization happening. So anywhere, everywhere digitization happening. Because of digitization, your bookstore is gone. They become e-book now. Your yellow page is gone. Your record store is gone. Previously, you can go to a video shop, and now everything is available on the internet because of digitization. All these are digitized. Prime movie, you can get all the digitized movie at you can see any amount of movies now. And new movies also now it's been screened on this because of digitization. Then you go streaming. Now the streaming also become easy now. Once the 5G is coming, the streaming will be much more easy now. Now the 4G, you see so much advantage of streaming of your songs or video or movie, anything. In taxis now. So that is completely digitized. Now you don't, you cannot call it a taxi. Now you have to only through app, you have to register, it will come, it will give you GPS phone, it will become very simple now because of the digitization. So like that, all industry is going to be digitized through IoT. You will see that media is digitized now, trade has been digitized, mobility has been digitized, call it taxi, everything is digitized. Tomorrow automation, automatic car, electrical car is going to be still more digitized, much more information for you. Health, discrete process industry, energy industries are more complex. It's going to be, it all take time. And there's also going to be more complex industry. Is slowly more research is going on, so they'll digitize completely on that also. And when you want to use that digitization, or how do you do that? So as I told you, you are going to use a PLC, DCS for running the machinery. Then over that you put gateways, put additional embedded controllers to log onto all your data. All parallelly, the data will be logged onto through a gateway to the cloud, where they'll do the analytics, trend analytics, everything can be done. Whatever I'm telling, condition monitoring, everything is going to be there into that. So a lot of chips have been designed for this. For a lot of many design has been done. So for the digitization, this is one of the one. You're building a industrial IoT. This is from I think NXP. That is one of the computer manufacturer. If you see the right side, all the real-time networking protocols, Ethernet IP, Profinet, CAN bus, Perforbus, all these are needed to connect all your equipments. Like I told you, the first Delta-based vector control system, you can connect to that. Then you can connect directly sensors also. Then the left side is they have all the protocols like MQTT, all these protocols for connecting to this to a cloud. So you can have a real-time control or controlling the PLC or whatever the equipments in the industry. Parallelly, this also can be connected to the IoT for digitalizations. So you have many chips like that. We have another chip also. This another chip is called from Net. So they call it a NetX90. Very powerful, dual core with a lot of protocols. Profinet, all the protocol can be implemented. So this is meant for IoT implementations. And okay, so now we are talking about so many things, but still, and the issues is covering a wide variety of usage, various environments like agri, healthcare, then transportations, serving diverse requirements. So no single wireless standard can adequate for IoT. It's not that Zigbee can solve all the problems. It's not that LoRaWAN can solve all the problems. It's not that Wi-Fi can solve all the problems. So it depends on the applications you have to choose. Numerous wireless standards available, spreading over multiple frequencies using different communication protocols. Supposing you're using a 4G for acquisition of data, you're going to spend money. If you're going to use LoRaWAN, it's free. Once installed, it's going to be free. There is not a charge at all. So like that, you have to choose a particular one because for different for your application, for your this one. Choosing right protocol, wireless connectivity, gateway technology is a really challenge. You need a lot of experience. We got a lot of number of this one wireless technology is evolving. I think people are doing a lot of research and they're going to introduce more new things, more new controllers. We had a previously 8051 about 10 years back. 8051 is very nothing now. So now they had a Countess M4. Now it is moving towards Countess M3, M33 with artificial intelligence. So many things they're going to dump. RTOs, everything going to dump in the front end itself. And one problem is 8051 will take less current. Now the Countess M3 also taking less current than 8051. So because of the advancement in the process industry, that is the chip applications, and the more you have more like cadence, you have more softwares to design ICs and everything more efficiently, less power power consumptions. So all this and this table gives you the spectrum of what technology, what is the advantage, what is the speed, what is the coverage of distance, everything. So we'll not go deep into that. It's also available to you. So as I told you, these components for IoT is sensors for different. There is a basic of that. Then we connect to all these sensor connected to a wireless board. You can choose any of the board, a powerful gateway, cloud computing, and big data analytics. So this is gives you, if you understand that, then IoT is understood. So you have the left side, bottom side, you have PSOC 6. That's one of the embedded control dual core. That's one of the popular one. Every day, if you see this today is very good. Now tomorrow you see the NX will be very good. So and ST Microelectronics is very good. Or Texas Instruments is good. Or in Nordic will be good. So many people are introducing silicons into that. There's a lot of shortage on that. So this one captures all the data and sent through wireless technology like Wi-Fi and Bluetooth to a gateway and a router. Then go to the internet. Anyway, you can connect to internet. So how you connect to the internet? Through internet, you go to the cloud computing. You see that I'm talking about how this cloud computer is organized. You have a physical hardware, over that you put your operating system, over that you call it as a virtual layer, virtualization software, over that you create a VM. So in one 40 core or 56 core computer, a server computer, you can have a number of virtual machines. So with the hardware configuration. So this virtual machine only you're going to configure. you are going to log on. So this is a data center configurations. So this is a full. If you understood that, then we know what is IoT components. So this is one of the components I already told you. So number of sensors they are putting into the market. So market every day there's a new sensor coming in. So this is some of the color bed sensors, light sensors, accelerometers, gyroscope, and humidity sensor, and MEMS microphone. The microphone itself, so many things are coming in now. Pressure sensors, MEMS pressure sensors. And this is one of the latest sensors, ambient light sensor from Texas Instruments, humidity and temperature sensors, hollow bed switch sensors, and this is water meter, LoRaWAN based water meter from famous company from French. I think this is what they're buying from all the Indian this one, and this is a regular flow sensor with the electronics built into the part to support LoRaWAN. LoRaWAN itself is a big subject, so can travel over 22 kilometers. So we have about houses of 1 lakh houses can be completely connected and can be monitored to this without any. This is another LoRaWAN based sensor. There are many sensors in the medical field. So I think BRC they are now fabricated one cheaper ECG machine. This is the ECG machine cost very less, and this can be this ECG can be sent to anywhere. Only this IoT will go to the IoT. So the advantage is this is the telemedicine. The intelligence doctors or very experienced doctors will be very few throughout the world. So this information goes to them. They can detect, they can find out what is the problem and give you a command on that. So that way, this IoT is playing major role on that. So this is like a lot of sensors that I'm just covering only one. Yeah, and sensor actually for a smart agriculture. This is one of the solenoid valve. So many sensors are available for you. Humidity, leaves, grains. You put a camera. You can find out the health of the leaves and everything. Then watering. This is done by the solenoid valve. This I think is from Italy. So not from Italy. It's straight, very rugged and very not much costly also. So this is one of the actuators available for you to do that. And you have a lot of embedded controllers with built-in RF sections from Texas. Pretty many people. This if you take the Carcass M4 with the Bluetooth with Zigbee and everything. This is called a CC2640 multi-core, multi-protocol ICs are available now. So this is another processor. And this is from ST Microelectronics. They have Bluetooth and Zigbee together. So one of the very recently released processor. This is from Microchip, another company from LoRaWAN. And you have a lot of SoC, that is system on chip processor also. This is Prestock 6 from Infineon. It's got a dual core with the Bluetooth inbuilt into that. So now Bluetooth is previously not used for a mesh networking. For a house, if you have a house, you want to do that, you have to use a Zigbee. Now you can use Bluetooth also. This is so powerful with so much features. It can be used to build your wearables like watches, smart watches, and security. A lot of security. The security is one of the big things. There's got a lot of security and a lot of solution for internet things can be done. In a doorbell, we have this is one of the beautiful applications for IoT. You have apartments or houses. You can fix this doorbell. Previously, it is a simple system. Now it has become very sophisticated system with the image processing, everything, and it can be transferred to the IoT. So you can detect the visitors can be detected very easily and can be alarmed in places. So another component is the gateway. The gateway is is a very one of the beautiful component for the IoT building up. Every manufacturer like Intel, Dell, every computer manufacturer is making it. If you go to the site to ask for the gateway, you will see a lot of features, everything. Usually the features of a gateway should be like this. Processor has to be powerful, memory, field inputs, field protocols, IoT platform, all these are features. Let me cannot go deep into it. This gateway should satisfy all these things. Time stamping, edge processing, everything should be available there. So this is done by one of the company based on Intel Atom. This is supposed to work without any fan, 24/7 and 360 days. Completely it should work. And it's got a dual core computer and everything. And these are the features. So anything can be connected. It can be anywhere, any application you can configure. So they give me Dell has got a gateway. So usually it will be on a DIN standard. You can connect with the DIN standard. You can mount it on a DIN. This one. Dell has got a 5000 series, industrial strength and everything. It supports number of operating system. It will support Amazon, all this gateway, all the IoT platform will support. These are the features of that IO connections, USB, serial interfaces, wireless connectivity, softwares. This is the application of that. This is another beautiful. This is done in Europe. They using it in one of the factories. So I've taken that. So it has got a beautiful features. So let me not go deep into that. So it will directly support MES ERP system. Directly will support. MES coming a big way for industrialization. This is a Siemens gateway. So Siemens 2040 is based on Intel Galileo boards. It's an open source board with a lot of interfaces, everything. So work on Yocta Linux, open source. So all programming software is available free for the students, especially. It is a very good platform, and they can run directly. The next one is very recently they come. It's a 2050 IoT 2050. They have a 2040, 2020 meant for students. 2040 is for industries. 2050 is the latest one. It's based on a AM6548. This is a Texas Instruments processor, 4-core processor. It has got a Profinet, everything, and will be there. This is a really beautiful Linux support. It can be a very good front end the edge computing also. The Supermicro is one of the motherboard manufacturer, like Gigabyte. So they also make a gateway. So I'll not go deep into that. This is based on a 7th core Intel processor. Unlock device, another manufacturer, they got a lot of solutions for IoT. They make sensors, they made accelerometer. Their accelerometer is more popular. So you can put into all the rotating machines. Their accelerometer is the more power. Everybody builds a condition monitoring system based on this accelerometer. So this gives you a vibration pickup. From there you write a software with automation. You will have a condition monitoring system. Then for so they had an arrangement with in New England. They have a lot of farmers, small farmers. So they made arrangement. They are tied with the unlocked devices for better, faster harvest and sustained growth of tomatoes. So you know the agriculture is really horrible. I don't know when the tomato is when the plant will die. When you need a lot of things has to be understand very nicely. And so this. So unlocked devices, they develop a lot of sensors, gateways, and they put it into the cloud, and a lot of analytics. From there, they go to the farmers. The information goes to the farmer, take advice. I mean, from their instruction, they feed water or they feed fertilizer and everything. So they get a better. So this is what they call as the Internet of Tomatoes. So they call it the Internet of Tomatoes. So better harvest, sustained growth of tomatoes. They monitor all this. They have unlocked devices. They put sensors for shade, sugar. They keep on adding more. But ambient light also may be a problem. So many things for better harvest. And it will be in the cloud. So they'll give you for 5 years data. If in the cloud, they can get a better instruction to the farmers. And we are really strongly producing a lot of things, solutions for IoT. So basic technology for students understanding for experimentations using Raspberry Pi and Arduino. For industrial version, we use 2040, 2050 and other this one also. And then we have a lot of sensors, wireless topology, cloud we can build a entry-level cloud computing and big data analysis. The whole thing end-to-end we can do that. And so the gateways, we use a Raspberry Pi, but everybody is familiar. But that is not used in the industry because it is not labeled. So it is meant for experimentation in the lab. Concept of proof, you can do that. But then you have to move into the industrial gateways like IoT 2020, 2040, 2050. And then we can also use AM335X, Beagle board. That's also cheaper. It works on Linux. And AM5729 is another beautiful board with the artificial intelligence, a multi-core inside. So the AM6747, that is what the industrial, that is what Siemens has done, the latest one. That is also very powerful. Then a lot of sensor nodes, Artus M4 based wireless sensor node, our own boards, keyboards, so many sensor nodes are available. Many sensors we are able to provide. These are one of the components, and you can play with that. This one. Then you have special sensors, no? That is all normal low-cost sensor. We have special sensors for IoT implementation for special applications. And this is advanced sensors like IoToMax, Then we have home run, environment sensors, weather measurements, so many sensors. We try to cover maximum possible applications possible. And this is the total structure of our implementations. We have a router to the cloud. You can form your own cloud, or you can take it from NetMagic. So many people are Amazon. Everybody you can have. You can you can buy the remote server. You can start implementing. So we put 3 servers here, 3 gateways. One is Raspberry Pi, another one is IoT 2040, another one is from AM33X, that is from Beagleboard. So you can keep on improving many sensors. That will be a good exercise for the students. So how we can, if we go to the industry, I don't think they all use it, they'll use something else. So it is getting exposed to more gateways, more sensor nodes. I think this is the structure of that. So each gateway we have put a cluster of nodes. We have put a cluster of nodes completely here. So that's a total system of that. Then this is the individual one. We are trying to expand one section of that AM335X. With that, we have connect a lot of sensors and everything. So that I referenced also. This is from Raspberry Pi. This is from 2040, all the clusters. So they are all routed to a cloud. Then this is a sensor node in details, which already I was talking. We need a debugger to, if it is your electrical engineer, electronics engineer, this will be much more useful. You can download a protocol, CP protocol from IEEE site, you can download that, then you can modify that. If it is a single sensor, you have to modify. If it is a multi-sensor, you have to modify. And then topology also. If you are going to use it in mesh networking, you have to modify the protocols. So which you can do that. There will be more good exercise for the students. So we can do about 22 experiments on CP alone. We can do that. So this is the development environment I have workbench and everything. This IDE. This is a C compiler for developing or configuring on that board. So you have the same thing like a Bluetooth board. Then you have a 32-bit ARM processor for IoT modes. We have a lot of this. We have about 5 sensors and more topologies, more wireless topology into that. This is the details of that. And sensor modules, so many sensor modules we have. The details of that. I'll not go deep into that. We support Raspberry Pi. There's the details of that. And AM335X. This is one of the industry more rugged than Raspberry Pi. That's what they're telling. And that's the details of that. This works on a Yocta Linux. You can configure yourself. This code you can take as an exercise in your lab. You can download Yocta Linux, write drivers, configure. That will be a very good exercise for the students. And this is a 2040. And 2040, it is a completely open platform. It can be integrated into the SCADA and DCS, whereas Raspberry Pi cannot be do that. But this can be done. You can use that. And 2050 is the latest one, based on a 6548, based on a Linux. So it's open structure. It's almost everything is open. So you can configure yourself and write software, everything. More hardware features they provide. You can use it for your own applications. If it's not needed, you can leave it. And this is the implementation of that. 2050 or 2040, this implementation of that. And edge computing is becoming more and more popular. That's all. You should definitely do that because more hardware is coming out. With few years back, it's not possible. Now, more algorithm, artificial intelligence, we want to put in neuro engine has to be there. A powerful EDSP, powerful engine should be there. So all these are now possible now, and it should take less current. So there are a number of ICs are available. AM572A, AM676448, that's from Texas. NXP, Layerscape processors, ST Microelectronics, then Creo, that is another processor very recently released from Xilinx. It is one of the beautiful processor. There's benchmarking, Jetson and other things, all the higher-end processors are available. They are doing much better than that. So this is one of the, this is from NXP. So you see the features, you have a number of cameras, you have so many things all available with that. This is the features of that. 4 Cortex A53 processors, 1 M7 processor, and 1 Cadence Rinsila DSP up to 800 MHz, neural network processing unit that is also available to that, so that you can use artificial intelligence and machine learning also you can incorporate into that. So you have 32 GB RAM and everything. So it's a front-end machine. You can put it in the front end, you can do that. This is only for learning. Otherwise, you can make it squeeze it to a small board. You can put a camera and everything. So camera is one of the mission system, one of the major component for industries. So this could be helpful. And like the same thing, Kriya has come, but I have not put the picture because it takes a lot of time. So commons, this is commons of the same board. So this another process has got a 16 core 872. I think the 710 also now comes. 710, 510 also now come from that ARM processor. This is from 72. This is one of the most powerful processor. They have 716 of that in the front end. You can use that, or you can build a gateway based on this. And the front end, this is one of the kit for sensor nodes. And cloud server. So I think the final stage, I'll take another 5 to 10 minutes to finish up. So can we have time, sir? Hello? Madam?
Yes, sir. Thank you, sir.
I will have another 5 minutes, then I'll finish up there.
Yes, sir. Yes, sir.
This the final component is the cloud server. So another important components. You can build your the cloud server is very important because the need of cloud-based solution for IoT. When you're dealing with the IoT, you'll have you generate a huge data. You need a servers. You need a remote server. We call it as a cloud server. So the IoT cloud, it stores, manage, and compute and analyze. That's what the analysis all your data with the plets. It gives you support to the Android, iOS based version based smartphones, and this is called data centers. Your cloud computing is called data centers. Data center is growing. So you have 2015 it is growing, going to grow by triple, and the public cloud service is going to touch 47.4 billions. So it's going to be a big source. A lot of data centers have been put. One of the data servers is called NetMagic. It is in Pundamali. They have a cluster of servers, everything. So we can call this cloud servers based storage computing will offer a very rich architecture, scalability, and flexibility to store the previous data. It has got three types of cloud. One is a private cloud, so it's completely in the remote side. Public cloud, private cloud is in your college or in your own premise. If you have, it's a private cloud. Your public cloud is a data center. Hybrid is both you can use. Supposing in the ship you want to have your own cloud server, then you will call it as a private cloud. Or you are going to use a public cloud both together, then you call it as a hybrid cloud. So this all used for real-time data capture, visualization, data analytics, data decision making, and device management. So you can hire also. This is from Google. This is one other service you can go to. IBM, you can service Amazon, NetMagic. For this configuration, Linux-based machine for the 4-core, they charge about 12,000 rupees per month. So I think if you go to build a volume, they'll reduce it also. And so you're having your own server, you can go for this. This will be cheaper, and this will be easy. A lot of scalability, everything is there with that. And then finally, all these data, people, machines, IoT, all these are going to generate huge data, will grow. Okay? Like smart metering, stock market, all medical devices, all cars, industries, home linked to internet, everything is going to generate huge data. So this volume of data is too large, too complex, to maybe too short-lived. Like email, or will be too short to live, too unstructured to be processed with the regular types of computer. You need a cloud computing to do handle this. Your data center will be like this, and after collection, you have to process that. The data is to be processed, and data is going to come from everywhere. Digital cameras, everywhere is going to come. So the big data, the scientists use this data to examine climate, earthquakes, epidemics, corona. Corona also a lot of data is going to come, but maybe we are not able to meet the demand of corona's problems. But anyway, tomorrow they are going to do that, and it'll all be to the cloud only. Government agencies, CBI, IT, comb this huge data, volume for terrorist activities or for good things like corona. What is happening, how to control that, all this can be used in this data. The present data used to focus the future or solve the future problems. And to build that, so in your college you want to build this, you have a number of servers, entry level servers are there. Basically you can build any servers using i5, i7, i9, say on. Basically you should have multi-core, number of cores should be high, and it should be VT enabled, that is virtualization enabled. So if you see that this i5 should be VT enabled, that is virtualization enabled. So if you see that this i5, it has got about 6 core. So this i7, it got 8 core. i9 has got about 8 core with the number of thread also is about 16. This is a Xeon. Usually Xeon processor used for building your servers. This is platinum. Its number of cores is 28. Number of thread is 56. There is another one, 56 cores platinum. 56 cores platinum with the 56 cores. So number of variants. I think if you have a 10 socket, I think maximum this cores can score for 8 socket. Even motherboard, you can have a 8 socket. So you going to use 56. Platinum. This